So good morning, everyone.
Good morning, Ravi.
Morning. Morning, Clefin.
Morning.
Hope everyone's doing well. So we'll go ahead and I guess we'll go ahead and start then. Right.
Open space, Pak. Kita mau akreditasi 2015, kita buat kita cekat gitu.
So yeah, I'll go ahead and start. So no worries there.
Yep.
Right. Cool. So hope everybody's doing good today morning, and today we'll start back with what we left off yesterday. So basically we stopped at RAID 1.0, right?
Right.
Okay. So the concept of RAID 1.0 basically is what we call nested RAID, right? So simple enough. What happens here is basically you're doing a RAID 1, then you're doing a RAID 0. What do you mean by doing a RAID 1? So you can see here D0 basically goes into a RAID 1 group. Then you have D0, D0. And then D1 goes into another RAID 1 group. D1, D1. So what happens here is you're doing RAID 1 first, then RAID 0. RAID 1 first, then RAID 0. So that's what they call the nested RAID. Simply, that's the way. Okay. So yeah, fairly straightforward. It's just combination of two different RAIDs. That is the nested RAID concept. So nested RAID, you'll have like RAID 1.0, RAID 5.0. You'll even have RAID 6.0, right? But barely people, or generally people don't use RAID 6.0 that much because you need minimum of 8 disks. So that's the difference between the different RAIDs. So you just have to understand how they do the RAIDs. So for every data, you do a RAID 1 first, then you have a RAID 1 group. And then the next data, you do another RAID 1 group. Basically, you're doing a RAID 1 and RAID 0. So the second data goes here, another RAID 1 group. And that's how it works. So outside of the group is basically a big RAID 0 group. You can see here, this is RAID 0, right? So RAID 1, RAID 0, RAID 1, RAID 0, RAID 1, RAID 0. So data is basically mirrored into two different RAID 1s. This is, well, this kind of RAID, basically what's the differences? Simply means you can fail 2 disks in 2 different RAIDs. Okay, if the 2 disks fail in the same RAID, then yeah, the RAID group is gone. But if 2 disks fail in 2 different RAIDs, you still have your RAID group up and running, right? In this kind of situation, no problems. But in this kind of situation, your data is lost. So that's why they call it, yeah, a nested RAID with a higher level of protection. That's it. Make sense? Any questions? Okay, let me open my chat here. Okay. Yeah.
So mirror only for the left side only or right side only?
So basically, well, like you said, sir, you have 2 RAID 1 groups. So for every data, you do a mirror. So data D0 will be mirrored into 1 group. Then you'll do a RAID 0. So your D0 will go into RAID 1. The D1 will go into the other RAID group. And then it will be mirrored. Then D2 will go into this group, mirrored. D3 will be mirrored here, and so forth. And that's basically how it works. So basically they're saying inside the RAID or inside the RAID 0 group, there's 2 RAID 1 groups, right? So that's what's called nested RAID, that's all.
Okay.
So this kind of RAIDs, well, we have certain issues whereby you have a minimum number of disks. Minimum number of disks is 4. This is the bare minimum. You must have 4 disks. Okay? And if you want to specify higher size, The next jump will be 8. Then will be double, right? So that's the number here. That's basically the problem. So you have to have minimum even number of disks in both groups. Okay. So yeah, I don't know whether I updated it. Oh, hold on. Cool. Oh, I didn't update this one. Yeah, but I put out the updated version. I have one there. But you can see here just from the number of sizes and all that stuff. So you have to basically add n plus 2, basically n plus 2, something like that, right? So that's, yeah. So basically the questions they'll ask you is minimum usually and the number of failures, okay? And of course, yeah, here for RAID 10 and RAID 50, you can see you can fail 1 per cluster, okay? So don't worry about that yet. So do we understand RAID 1, 0 at least? No issues, right?
Another question, what the advantage of this method?
Well, here main advantage is protection. Basically, you can fail 2 disks because you can fail 2 disks in 2 different RAIDs. Like in a normal RAID or 1-0 group, if you can fail 1 disk, right? But here you can fail 2 times the disk, so still can run. Basically, more protection and a bit more speed in some sense because they do RAID 0 and RAID 1.
Okay.
So in total, generally people do not use RAID 10 that much. Why? Because of the amount of disk space. At the end of the day, it's the same as RAID 1 group, whereby you only get half the disk space. So if you have 4 terabytes, you're only getting 2 terabytes. Yeah.
Okay.
And the minimum amount of disk is a bit hard for some people to cope because, yeah. So depending, you can use RAID 10, but RAID 10 is generally used for all those applications or data that you want higher amount of protection, right? Or you can use the next one. Okay, you can see user data here. Oh, they don't even show it. Okay. The next one is RAID 50. So RAID 50 carries the same technology. Basically, your data is done into RAID 5 group first. So you can see here, this is a bit more complicated, but your D0, D1 will go here. Then they'll create a parity. Then your D2, D3, parity, right? D4, D5, parity. D6, D7, parity. Okay? So it's basically doing 2 different RAID 5 groups, right? Make sense? So if you understand the previous RAID technology, then yeah, this RAID technology is pretty simple. But however, the minimum amount of disks is 6, right? Because the minimum amount of disk for a RAID 5 group is 3, so you have 2 times the RAID 5 group, hence you have 6 disks as the minimum. Make sense? Any questions?
Yes. Yes. I would like to ask whether we can do the other way around. For instance, for RAID 10, does Huawei recognize RAID 01 as well?
There is no technology for RAID 01. I think so. Maybe there is, but I would not see the protection in that way.
Because I've read it elsewhere, but I think it is plausible because we have first up so we have 2 RAID zeros, 2 RAID zeros, and they are the mirror of each other. So we can lose multiple drives, even whole cluster if it is in a sufficiently disastrous situation. We can lose whole cluster and we're still good.
But yeah, that may be for different vendors possible, but for Huawei, of course.
Okay.
Huawei, no worries, no worries. but Huawei doesn't follow RAID 01. So Huawei only has RAID 10 or Phi Zero. Because they have another technology which will just come up soon, that basically complements all these RAIDs. Okay. So they don't use RAID 01 because they have something called the RAID 2.0 plus. Okay. Because of that technology, the block virtualization technology, they don't see the need for RAID 01. Make sense, sir? Any other questions?
Yes, Mr. Brevan.
Go ahead, sir.
Is it possible for you to re-explain about parity? Because yesterday I still have an issues to understand.
No worries.
Yeah.
No worries.
Yeah.
So just maybe parity we take RAID 5. Much more easier to understand.
Or maybe in another section, or yeah.
No worries, no worries, no worries. I mean,
Thank you. Yeah.
I mean, no problems, no problems. So let's just take this as actual data. So you say the data is 101110. Why not? Okay. So this is the actual data. So how you save data in basically RAID 5 using parity itself is data will be saved as 10. Then you'll build a parity. Then you'll save data in 11. Then you build a parity. So let's just call it parity 2. Then you'll save data 10 and parity 3. Okay. So what that means is when you save data, then you build a parity. So your parity is using the XOR. So it's the NOR bits, right? So 1 NOR 0, basically your parity equals 1, right? Then 1 parity, 1 NOR 1, your parity equals 0. 1 XOR 0, so this guy, your parity equals 1. So what that means is basically in this situation, if one disk dies, you can rebuild the disk. So basically you use the parity and then you XOR, you'll get back here 0. You use the parity, you get back 1. Parity, you get back 1. Make sense? Or if you want to see it easier, RAID 3. Sorry. So it's easier to show in RAID 3 because you have one dedicated parity disk, right? So just go as normal as how you save data 101, 111, 011. Let's just say this is the actual data. So A will be saved first. So data A will come inside A0, A1, and A2. So that will be 101. Then you'll save the B data, which is 111. This is actual data in that sense. Then you'll save 011, right? So how you calculate parity is basically you XOR each other. So you start from the first data. The first data is 1 XOR 0. So your data will be 1. Then you XOR again, 1 XOR 1, your data will be 0. 1 XOR 1, data will be 1. Data will be 0. Then you XOR 1, data will be 1. 0 XOR 1, data will be 1. XOR 1 will be 0, right? So the main purpose of the parity is to rebuild the disk. So if any of this one disk fails, right? So any of this physical disk 1, physical disk 2, or physical disk 3 fails. So let's just take, for instance, this disk fails, right? You can use the current data or whatever data that's left and rebuild the rebuild the disk again. So how they rebuild the disk is still using the XOR sequence. 0 XOR 1 equals 1. XOR 0 equals 1, right? 1 XOR 1 equals 0. XOR 1 equals 1. 1 XOR 1 equals 0. 0 XOR 0 equals 0. So it basically rebuild the failed disk. Does that make sense, sir? That's the main purpose of parity.
Yes, yes. So it only happened in RAID 5 and RAID 3, right?
Currently for our course, yeah, RAID 5 and RAID. The RAID 1 and RAID 0, RAID 1 is called mirror, RAID 0 is just called striping. That's all.
Okay, thank you, sir.
No worries, no worries. Any other questions? Let's go through this. Okay. So any other questions regarding anything anything to do with traditional RAID? So this, yeah.
And, excuse me.
Yeah, go ahead, sir.
Okay. Why there are no RAID 4?
There is a RAID 4.
Yes.
It's just not covered in under Huawei. Because Huawei doesn't use RAID 4, that's why they don't cover it. There's a RAID 2, there's a RAID 4.
Okay.
No worries, no worries. Any other questions?
One more, Mr. Previn. Can
Yeah,
you
go ahead, sir,
go
go ahead.
back to the previous slide?
Okay.
Another one before this.
Uh-huh.
Yeah, this one. Yeah.
Okay. So this is what they call RAID 6. RAID 6 is dual parity or double parity. So how they consider parity is basically they do a horizontal parity and then a diagonal parity, right? So horizontal parity is basically they color coded it here. So like these guys are one parity. So including the, yeah. And these guys are one parity, so including these guys, so forth. So they do horizontal first, then they do diagonal, right? So that's why you have two parity disks. So simply means RAID 6, you can fail 2 disks in the RAID group, right? And that's what they are trying to show you here. So if, yeah, go back. So here they are trying to show you a situation where 2 disks have failed, right? So if 2 disks fail, first they'll use the horizontal parity, which is D2, D7 here, whichever you can see here, the green stuff glowing, right? That's why they color coded this guy, because it makes it easier. So 2 disks fail, they will check first the horizontal parity. So D2 will XOR D7, will XOR P2, will XOR DP2. Then you'll get back D12. Then you'll do a diagonal, right? So then they will use these guys. Okay, so you can see here. Okay, so diagonal parity. Then they'll rebuild back D13. Horizontal parity, diagonal parity. Horizontal parity, diagonal parity. Horizontal parity, diagonal parity. Make sense?
Yes. Yes.
Yeah, so that's how RAID 6 works. That's all. Nothing much. But don't worry, for the exam, they won't specifically ask you how the RAID rebuild works and all that stuff. This is just for knowledge. Right? Cool. So no other questions regarding traditional RAID. So if you have questions, do ask them, no worries. Else we'll go into what we call RAID 2.0 plus. This is a Huawei block virtualization technology. Okay. Cool. Right. So no questions. We'll go into RAID 2.0 plus. So RAID technologies have evolved. So initially we have like physical RAIDs or basically software RAIDs or whatever, traditional RAID technologies. problem with traditional RAID technologies is like here, let's say you have two RAID groups. Maybe this group is RAID 10, right? So maybe this is a RAID 1. And then this group, the yellow guys, will be RAID, like say RAID 0. Right? So these are two different RAID groups. Problem is each RAID group only supplies whatever space they have in the group towards the customer, towards like say the servers, right? So when you're creating a storage space in a traditional old school RAIDs, the blue group, let's say you got 5 terabytes, and then the yellow group, let's say you got 6 terabytes, right? So these are two different groups, and when they provide storage space, this guy can go up to max 5 terabytes, and this guy can go up to max 6 terabytes. So you're basically splitting the disk into two separate like partitions in some sense. Okay, so that's what happens with traditional, really old school method, right? Then they developed what they call LAN virtualization. LAN virtualization takes the traditional method, but then virtualizes the what do you call this? The RAID groups. So you like say here you have the same thing, 5 terabytes and 6 terabytes. By themselves, they have together a total of 11 terabytes. But what happens in LAN virtualization? You virtualize the storage space into a storage pool, right? So this whole storage pool will have 11 terabytes of space added together. This is what they call LAN virtualization. And then from this storage pool, then you can provide a LAN. So you can provide whatever LAN. Maybe this guy is about 3 terabytes, this guy about 4 terabytes, and this guy maybe about, let's say, another 4 terabytes. So you provided about 11 terabytes of space, right? But you will usually not use the full disk. So you'll use maybe about 10 terabytes here. You leave 1 terabyte maybe for backup and all these things. Do understand they still use the physical RAID technologies. It's just that now they're using software RAID, adding virtualization into it, right? So with this technology, you can provide a larger amount of space because you can combine multiple RAIDs. That is what they have in LAN virtualization. Then we come up with a new technology called block virtualization. Block virtualization is basically the technology that RAID 2.0 plus uses, right? So this is Huawei's block virtualization technology, but in general, they have a general block virtualization technology, which is just called block virtualization. Block virtualization is, well, I will show you guys a video later on. You guys can watch that video, and then we'll understand better regarding block virtualization, okay? So how block virtualization works, basically you're splitting the blocks of the, let's say, disks into something called chunks. Chunks, then you have chunk groups. After chunk groups, you split it into what they call, I think it's, not mistaken, it's grains, I think. And then that grains are provided as storage space towards the customer, right? So it's a bit more of breaking down virtually your disks in a smaller segment of size so you can do better rate, like load balancing and all these things, okay? So don't take my word for it. So I'll just show you guys a video first of how block virtualization technology works. So it's only about like a 7-minute video. So that's why I usually show this to my students first, because when I start explaining, people tend to not understand fully how it works, right? So this is a RAID 2.0 video, and it's actually done by Huawei itself. Maybe I'll lower the volume a bit. Same as system, audio settings. wonder if you guys can hear this. Okay, double check this. Can you hear this? Can you guys hear the video?
Not yet, sir.
Okay. Because usually there's some issues with the video itself, so yeah, just put it into a lower. Okay.
Maybe you need to share with audio.
Sorry?
Share screen with audio. When you share screen, there are some point. Yeah.
Is there such a thing? Oh, share sound. Okay. Now you can hear it?
Hello. Allow me to.
Okay. So we'll just put it in a bigger screen and let you guys see it. Okay.
Introduce you to the RAID 2.0 Plus technology employed in our Huawei storage products. This presentation is broken into two parts. In the first part, I will tell you about the advantages of Huawei RAID 2.0 Plus. In the second part, I'll explain to you how Huawei RAID 2.0 Plus works. First off, let's see what advantages Huawei RAID 2.0 Plus has over traditional RAID. In a traditional RAID environment, the disk failure rate is comparatively high. This means there is a high chance of a service interruption, and it can take a significant amount of time for the storage system to fully recover services. Because of the extremely heavy data and service flows on these networks, the storage system faces a serious performance bottleneck. Huawei RAID 2.0 Plus has been able to overcome the shortcomings of traditional RAID environments, enables the storage system to implement load balancing across disks, quick recovery of data on faulty disks, and to perform quick reads and writes. Load balancing among disks. In a traditional RAID environment, the workload distribution across disks is unbalanced. Thus, disks with a heavier workload are more prone to failure. This reduces system reliability. By contrast, in a Huawei RAID 2.0 Plus environment, workload is evenly distributed across all disks. This significantly reduces the disk failure rate and improves overall system reliability. Quick recovery of data on faulty disks. When a disk fails, in a traditional RAID environment, only the other disks in the same RAID group participate in reconstructing the faulty disk's data onto a hot spare disk. After replacing the faulty disk, the storage system still needs to copy the data back from the hot spare disk to the newly inserted disk. This copy back process is very time consuming. In sum, the data recovery speed in a traditional RAID environment is quite slow. However, in a Huawei RAID 2.0 Plus environment, when a disk fails, all disks in the disk domain participate in reconstructing the faulty disk's data. Compared with traditional RAID, Huawei RAID 2.0 Plus is at least 20 times faster in recovering the faulty disk's data. Specifically, Huawei RAID 2.0 Plus takes only 30 minutes to reconstruct 1 terabyte of data, whereas traditional RAID needs at least 10 hours. Fast data recovery enables users to use disks of 4 terabytes or larger in the storage system. Quick reads and writes. In the RAID 2.0 Plus environment, all disks in the disk domain, that is, over 100 disks, are involved in the data access process. This greatly improves the read and write speeds of the storage system. By contrast, in a traditional RAID environment, only disks in the RAID group, that is, approximately a dozen disks, are involved in the data access process. Thus, the read and write speeds of the storage system are comparatively much slower. Huawei Enterprise Storage features million-level IOPS and microsecond-level response speed. This is at least 10 times faster than enterprise storage products using traditional RAID. Now for the second part of our presentation. How does Huawei RAID 2.0 Plus work? To explain the inner workings of Huawei RAID 2.0 Plus as clearly as possible, I will first cover some basic terms, such as disk domain, storage pool, hot spare capacity, and LUN. A disk domain is a physical storage space consisting of multiple disks. Some space of a disk domain is used to create storage pools, and other space is used as hot spare space. In a storage pool, multiple LUNs can be created. After being mapped to hosts, the LUNs are ready for data access. Now I'll describe the underlying virtualization used to implement Huawei RAID 2.0 Plus. A disk domain contains one or multiple types of SSDs, SAS disks, and NLSAS disks. A storage system can accommodate multiple disk domains, over which fault isolation is implemented. Disk space in a disk domain is divided into 64 megabyte physical spaces using block virtualization. Each physical space is called a chunk, abbreviated as CK. In a disk domain, users can create storage pools. A storage pool consists of multiple CKs from different disks in the disk domain. Users can create multiple storage pools in each disk domain. Each storage pool can contain CKs from one or multiple disk types. In a storage pool, CKs of the same type can form a chunk group, or CKG, according to a RAID policy. Users can choose an appropriate RAID policy for a CKG according to the network's service requirements. In a storage pool, a CKG is divided into multiple extents. An extent is a logical space smaller than a CK. The size of an extent is not fixed and can be adjusted. The default size is 4 megabytes. An extent is the basic unit for space allocation, space reclamation, data statistics, and data migration. In a storage pool, users can create multiple LUNs. Each LUN consists of multiple extents. The extents of one LUN can be of the same type or of different types. Users can adjust the capacity of a LUN dynamically according to the network's service requirements. For example, if the initial allocated capacity of a LUN does not meet the service requirements, users can apply for new extents to expand the LUN capacity. Storage space in the storage system is mapped to hosts by LUNs. Now, let's see how a piece of data is delivered after a host writes it to a LUN. When it reaches the LUN, the data is distributed to multiple extents. Since the extents come from multiple CKGs across the storage pool, the data is distributed over multiple CKGs. Since each CKG consists of multiple CKs from different disks, the data is evenly distributed across all disks in the disk domain. Based on this even distribution of data, all disks in each disk domain are effectively load balanced among each other and can respond to data access requests, resulting in quick data reads and writes. In addition, because data is evenly distributed, all disks in a disk domain participate in data reconstruction when a disk fails, resulting in comparatively quick recovery of the faulty disk's data. That's all for our introduction to Huawei RAID 2.0 Plus. If you want to know more about Huawei storage products, visit enterprise.huawei.com. Thanks for watching.
Okay, so kind of got the basic concept. If you have any questions regarding the basic concept first, then we'll move forward, right? So that's how block virtualization technology works. Basically, all block virtualization technology, not only Huawei RAID 2.0 Plus, but Huawei RAID 2.0 Plus is Huawei's version of block virtualization. There will be like a HP, SimpliVT, and all these things. They have a different type of block virtualization technology. Okay. So if you guys want to know where to find the video and all that stuff, you want to watch the video again, basically you can find it in my Google Sheet here, right? So I'll just share that in the link. Okay. So I'll share that in the chat. If you guys want to watch it, no problems, right? Cool. Right. So from that itself, or from that video, we have to understand there are different levels of things that happen here. So we'll start with first the disks, or what you call the physical level, right? So physical level in Huawei, you can add hybrid storages, you can add multiple types of disks. However, in flash storages, you can add flash disks. So we won't talk about flash storages first. We'll talk about hybrid storages. So let me put some annotations here. So generally, you will add all your disks into the Huawei storage first, right? So physically attach all the disks and all that stuff. When you attach all the disks, the Huawei storage will then rectify, okay, how many disks are attached, what kind of disks are attached, where are they slotted and all these things. And then it'll virtualize it. And from there, you can create basically what they call a disk domain. Right? So a disk domain is basically a logical version of all your physical disks, right? So whatever disk you put inside, it can be SSDs, it can be SAS disks, it can be NL SAS disks. These are the three types of disks that they use in Huawei storage environments. If you're talking about hybrid storage, these are the only three disks. Flash storage, only SSD, right? So you'll add all these disks. Physically, you'll attach them to your storage, or you'll attach them to your disk arrays and all that. And from there, it'll be virtualized into a disk domain. So the first thing you need to do in a Huawei storage is choose your disk domain. So your disk domain can consist of a single type of disk. So maybe you just want to create a disk domain of full of SSDs, right? So you can create like a SSD disk domain. Or you want to add multiple types of disk in a disk domain, so you can put like SSD and NL SAS into one disk domain, right? So this is a choice given to you, how you want to create it, right? You can even do something like this. So let's say you have one for SAS or SSD disks, sorry. So SSDs, let's say you have 10. Then SAS disks, let's say you have 20, and NL SAS disk, you have like 30 disks. So altogether, you'll have 60 disks, right? So you can create disk domain. So let's create disk domain 1. So I'll just call it DD. So DD1, maybe you compromise of 5 SSDs, 20 SAS disks, and maybe 15 NL SAS disks. So you must understand, when you create a disk domain, by general, you're removing the physical disk and entering it into a logical environment. So if you do something like this, so let me just put that maybe in a text format. So disk domain 1. You have 5 SSDs, 20 SAS disks, and 15 NL SAS, right? So what happens here is you're creating one disk domain with this amount of disks. So from the actual physical disk, this value is minus, right? So disk domain 1, you have this kind of disk, and then you can create disk domain 2. Okay. This domain 2, you can take the rest of the SSDs, or maybe you don't want to create it with SSDs, you just want to create it with 15 NL SAS disks, right? Then maybe you want to create disk domain 3, which is just full of SSDs. You can do it this way, right? So whichever method you choose, up to you, or you can just put it all the disks into one disk domain. Generally, people do that. So you put all the disks into one disk domain. Or you can split it up into different disk domains, up to you. But you must know, if you split it up into different disk domains like this, so if you do something like this, like disk domain 1, disk domain 2, and disk domain 3, the storage space, or when you create a storage pool, it will follow the amount of disks in the disk domain. So generally, if you split it up, you'll have lesser size of storage pools. If you put everything into one big disk domain, you'll have, of course, one big storage pool in that sense. Make sense? Cool. Any questions, guys, before we continue regarding this domain first? No questions? Cool. Okay, so once you create a disk domain, you add all your disk inside. Let's just say our disk domain, I'm just showing this as an example. So let's just say our disk domain, we put all the disks inside. So this is our disk domain, right? So once you create a disk domain, then they will ask you to create a storage pool. Okay, so the storage pool concept, first the disk will be broken down into chunks. So chunks are basically like, say you have one disk, you're breaking down the disk into smaller segments. So each chunk will be 64 MB in size by default. Okay, each chunk will be 64 MB. Chunk, the abbreviation is called CK. So one CK or one chunk will be 64 MB in size, right? And then you'll have multiple disks. So you can take the same type of disk and they will just create chunks of those disks. All those chunks from multiple disks will then create a chunk group, right? So a chunk group is basically chunks. So let's say they will logically create a disk this big, but it will be chunks from different disks. So this can be disk 1, this can be disk 2, this can be disk 3, and this can be disk 4, right? And then they'll attach it to a chunk group. Once you're creating your chunk group, you do not see this when it's happening in the back end, but once you're creating a chunk group, this is where you attach your traditional RAID policies, right? So you'll attach like a RAID 0, RAID 1, a RAID 5, RAID 6, RAID 10, whichever RAID policy you want, right? Once the RAID policy is given, once a chunk group is created and all these things, which is done generally on the back end without you going inside and trying to do anything, it's already automated. It's when you actually create the storage pool. So this is where your storage pool happens. Okay. So at this level is where you create your storage pool. Why? Because once you apply the RAID policy, so it doesn't matter how much disk size and all that stuff, but once you apply the disk policy, the RAID policy, the disk size may vary. So if you use RAID 1, of course, they will cut half the amount of storage space. If you use RAID 5, they use one disk for parity and all these things, right? So there'll be different sizes for different RAID policies on top of the block virtualization technology, right? So you have to understand that concept. So first thing you have to do is create a disk domain, right? That is a logical version. Once you create your disk domain, you choose how many disks and all that stuff you want. They will generally break down the disk already into chunks in the backend. Those chunks are 64 MB in size, and each disk will be just basically cut into logical smaller blocks. And that is what they call block virtualization. They'll cut it into smaller blocks. All those smaller blocks of disks, so like say in my example here, I have 2 disks, right? So these 2 disks, you'll have block 1, block 2, block 3, block 4, let's put it differently. Maybe this is block 1, block 3, block 4, block 2, block 5, block 6, block 7, and block 8. So once they create the blocks, they'll create the chunks. After the chunks are created, they will then attach it to chunk groups. So different chunks from different disks will be attached to a chunk group. So like here in this chunk group, you have 1, 2, 3, and 4. So 1 is coming from here, 2 is coming from here, 3 is coming from here, and 4 is coming from here. They create a chunk group that way. So it's from different disks. This is for the redundancy purposes and all this stuff. When they do the chunk group, basically that's when you are creating your storage pool. Later you will see when you do the lab, it looks so easy, like you just go there, okay, this domain, create this domain, virtualize all the disks, create storage pool. In the back end, this is what is happening. So they'll create a chunk group. From the chunk group, you add to a RAID policy. The RAID policy is then applied, and then you create your storage pool. Once the storage pool is created, you have your storage space required and all these things. Then you want to provide this storage space to a server. So a server will be somewhere up here. Let's say a server. Okay. Right? So to provide storage space to a server, what the storage pool will do, it will break down the chunk groups into extents. So basically, you will break down this whole chunk group into extents. Extents are something that you can change in size. The default size is 4 MB. The maximum size is 64 MB. And the minimum size is 512 KB. Okay, so you have to remember these things. This is the default. If you do not change the size, this is the default. Okay, so before we move forward, any questions so far? Or totally confusing? Yeah, go ahead.
So the extend like sector in this, like that?
You can say, if you try to virtualize the concept, you can't say it actually as a sector, but yeah, maybe that concept
like virtual sector, like that.
Virtual
for the LUN.
Yeah.
Yeah. LUN is like hard drive and extend like the sector inside hard drive, like that.
Yeah, something like that. You can put it that way. But because of chunk and chunk group, it makes it a bit more complicated in that sense, right? Any other questions? Sure, no problem. Confirm. Because a lot of questions will come out for this chapter. Generally, because it's a Huawei technology, they will ask you a lot of questions regarding RAID 2.0 plus. So you must understand, at least understand on a high level how it works, understand like the core mechanics, and then you should be fine. Okay. So what happens is you will virtualize your disk into a disk domain. After a disk domain is created, they will break down your disk into chunks. So chunks and chunk group, so this part and this part, so this part here is basically when you create your storage pool, right? This is your disk domain, the physical part. So if you're creating a storage pool, they will ask you to choose the RAID group size. When you're choosing your RAID group size, they are basically breaking down the disk into chunks and chunk groups. Okay. Only when you want to provide a LUN, so this is a LUN, from the storage pool, they will break it down into extents. Extents, you get to choose the size. Default 4 MB, maximum 64 MB, minimum 512 KB. Question can come, why do you want 512 KB and why do you need 64 MB size of chunk, extents, right? Why is this changeable? For different types of application. So like if you're saving data and you're just saving like videos or you're saving like audio files, in that sense, it's better to use a bigger extent size. So it's much more easier or faster to save your data, right? There is a bit of speed check here, right? So bigger the extent, the faster the data is saved. The smaller the extent, a bit slower the data is saved, but it's more better for like database applications. So database applications, you want to save data in very precise size. So the smaller the extent, you see mostly it's being used for databases. So like MySQL databases and all this stuff. Generally, they will use a smaller extent size. The bigger extent size is for large files, like large single files, like videos, movies, and all these things, right? They will use a bigger extent size, right? Generally, if you're not doing any normal stuff and all this stuff, 4 MB is the size. Any question? Everything is cool? No problems? All cool, huh? Oh, sorry. My bad. I was messing around with the participant things, but yeah. All right. So, confirm no questions. If you understand this process, then I'll just clear the page, make it look clean again, right? Okay. So, you must remember, first thing you do is when you add the disk inside this Huawei storage, you will create a disk domain. Okay. After creating a disk domain, the second step is actually creating a storage pool. Okay. Once the storage pool is created, then you can then create your LAN, right? So the storage pool, while you're creating the storage pool, you're basically breaking down the disk into chunks and then into chunk groups. This is done in the back end without you knowing, right? You don't have to, you don't see it happening, but this is done in the back end storage system automatically. So after the storage pool is created, you want to provide a LAN to the customer and all these things, or not to the customer, my bad, too much Huawei cloud stuff. So you want to provide storage space to the server. You'll have multiple extents, create a LAN. So the extent size is up to you. 512 KB minimum, 4 MB by default, and 64 MB maximum. Okay. Later on, you'll see something called grain and all this stuff, but that grain, don't worry about it yet. So if you understand this concept, then we are good. If you don't understand this concept, do speak out now. Because at least 5 to 10 questions will come out from this guy. Most of the time, I see at least 5 to 10 questions in any exam come out from RAID 2.0 plus. Okay? Cool. No worries then. Okay, then we talk about the RAID reconstruction. So RAID 2.0 plus, RAID reconstruction in RAID 2.0 plus is what they call many-to-many RAID reconstruction. So you can see the difference here. This is a traditional RAID group. So a traditional RAID group only disk 0, disk 1, disk 2, disk 3, and disk 4. So basically this is one RAID group, right? They are using RAID 5. Right? So you have 4 disks plus 1, basically 1 disk is your parity disk, and then you have some hot spare disks outside in your environment itself. You always must have hot spare disk. Even in RAID 2.0 plus, you'll have hot spare disk, but this is calculated automatically for you, so you don't have to worry that much. So what happens in a traditional RAID group? So if one disk fails, so like disk 1 failed, to rebuild disk 1, only these guys will work to rebuild disk 1. So you still have disk 6, disk 7, disk 8, and disk 9. These guys don't do anything yet because they are not part of the RAID group. So they will not, what do you call this, take part in the RAID rebuild sequence, right? Only these guys, so this guy, this guy, this guy, and this guy will perform the RAID rebuild and rebuild back hot spare 5, right? So hot spare 5 will now become the previous HDD1. So whatever data in HDD1 will be now in HDD5, which is a hot spare disk. Okay. After that, if you say you put back the disk, or if you change the disk, you basically remove the faulty disk, put in a new one. Hot spare disk 5 will then have to RAID rebuild, or what they call RAID reconstruct to HDD1. This will take a very long time. Like so you saw in the video, for 1 terabyte of data, to do a RAID rebuild or RAID reconstruct, it takes about 10 hours. Okay. This is how it works traditionally. This will work in the back end. When you slot in a new disk and all that, you will RAID rebuild. It will just keep working in the back end and you won't know it. But you'll feel your storage is getting slower and slower and slower, right? So if there's too many RAID rebuilds happening at the same time, generally your storage will be very slow. Okay? So that's what happens in traditional RAIDs. However, in RAID 2.0 plus, you take the same sequence whereby disk 1 now has gone, right? But because of how block virtualization technology works, basically your data is not sitting on one disk, right? So you have RAID group 5 here. Then you have RAID group or chunk group 1 with RAID 5. chunk group 0 with RAID 5, chunk group 1 with RAID 5, and chunk group 2 with RAID 5. Okay, so disk 1 has chunk group 0 and chunk group 1. Okay, so what happens is basically everybody with chunk group 0, so disk HDD 0, HDD 2, HDD 3, and HDD 4 will take part in the reconstruction of chunk group 0. Whatever data was lost in data 12 here will then be replaced with hot spare 96, right? So this is for data 12. Data 13, chunk group 1 will take part. Okay, so this guy, this guy, this guy, and this guy. So they're building two different RAID groups at the same time, right? This is how it works. So this is what they call the many-to-many RAID reconstruct sequence. This is also much more faster, so eliminating the time from around 10 hours so RAID reconstruct time from 10 hours to about 30 minutes. 30 minutes is already very, very, very good for us, right? 30 minutes RAID reconstruct is extremely good. If you're in the storage environment, every time you know there's a RAID reconstruct happening, it basically sends a lot of people going crazy and stuff. But because of how it works in RAID 2.0, you only need 30 minutes to rebuild the whole RAID group, to rebuild the whole HED1. 30 minutes is more than acceptable in some sense. Okay. Any questions so far? So today I think everybody's quiet already. Maybe too confusing. The video, yeah, I know it's a good explanation, but yeah. Cool. Okay, so this is how the RAID reconstruction works in RAID 2.0 and traditional RAID. Okay. So logical objects that we need to know. First, we have to understand the theory of chunk group extent and basically your volume and LUN, right? So chunks are from different disks, so right? So doesn't mean that chunks will be like you'll have your SSD chunks, you'll have your SAS chunks, and you'll have your NL SAS chunks. So let's just put it this way. So the blue ones are SSD, the green ones are SAS, and the dark blue ones are NL SAS. These are disk types. So SSD, solid state disks, SAS, serial attached Scuzzy disks, NL SAS, nearline serial attached Scuzzy disks. We'll talk about the disk types later on, don't worry. So you'll create chunks from multiple physical disks. So SSD, they will, okay, like so this SSD disk, they'll break it down into multiple chunks. From those chunks, which are 64 MB in size, so once again 64 MB, I will then create multiple chunk groups. So chunk groups will be from multiple SSDs, right? So the chunks are from a single SSD broken down. They will take different chunks from multiple SSDs. So this can be like, let's just make it a bit easier. Let's just call this whole SSD, SSD1, SSD2, and SSD3. So what, when you're creating a chunk group, basically you'll create a chunk group with maybe this guy from SSD1, this guy from SSD3, this guy from SSD2, this guy from SSD1, and this guy from SSD3. So all the disks are taking part in the chunk group. All the chunks from different disks, right? The second chunk group, yeah, it can be from SSD3, 1, 1, 2, 2, something like that. So multiple chunks from different disks will create your chunk group. This is all done when you're creating your storage pool, right? Initially, you're creating your disk domain, then you're creating a storage pool. And the extend part comes here when you're creating the LUN, right? So extends are either 4 MB by default, 64 MB max, and minimum 512. So you'll have extents from different tiers of storage. So SSDs, SSD extents, SAS extents, and NL SAS extents. You will then use these extents to provide a LAN to the servers, right? So multiple extents for multiple chunk groups will be created, and this is what we call a tiered storage, right? Tiered storage, that means you have multiple different types of disks, logical versions. Not tiered, that means you have a singular type of disk. So this guy is only using SAS disks, and this guy is only using NL SAS disks, right? Tiered storage can do a lot of other things, like you can do like smart tiering and all these things. So there are certain technologies that you use for tiered storage. There are certain technologies that you cannot use also, right? And then you provide the tiered storage volume towards the customer. So the customer is happy. He gets his storage space, but in the back end, this is how it works. Okay? So you must remember the flow. You must remember the flow, because exam questions, there is one question that will come out. What is the sequence for RAID 2.0 plus? Something like this, right? So they'll ask you something else before, they'll make it a long question. So like RAID 2.0 plus is a Huawei's RAID block virtualization technology, blah, 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 blah. Then the question will be, what is the sequence for RAID 2.0 plus? Then they'll give you A, B, C, D. I've seen E also, right? So something like this will come out. They'll ask you this question. So you need to know, okay, how is the sequence? Maybe I put it some, yeah, I just put it somewhere here. So how is the sequence? You need to know, like, okay. They'll ask you, okay, so the sequence will be disk domain to CKG to CK to LAN to extend. So you need to know what is the correct sequence, right? You need to know the actual sequence. So like actual sequence I just put here, disk domain to CK to CKG to extend to LAN. So you need to know the correct sequence. Else, yeah, it's kind of like a free mark sometimes. If you know the correct sequence, then you just choose the answer and that's it. Then you can move forward. But there will be generally about 5 to 10 questions from this chapter itself. So you need to know, like suddenly they might ask you a question, what is the minimum chunk size? Extent size. What is the chunk size? What is the maximum extent size? What kind of storage tiers can you use? Multi-tier, single tier, and all these things. Can you use SAS disk, NL SAS disk, and SSDs in the same storage? Possible. You need to know all these kind of things, right? So, from you guys, any questions? I'm a bit scared because everybody is so quiet today. Okay. So if no issues, then do tell me. You carry on. Okay. So first concept we need to understand is a disk domain. So a disk domain is like what they say here. It's a combination of disks, which can be either all the disks in the disk array or the disks you choose, right? So you choose which disk. After the disks are combined and reserved for hot spare capacity, this is done automatically. So the hot spare capacity in Huawei RAID 2.0 plus, you only have two options. You have either low or high. That's it. So if you choose low, it's basically for every 20 disks, you'll have one hot spare. If you choose high, for every 12 disks, I think you'll have one hot spare. That's how it works. There will be a sheet somewhere. You can check it out. Let me see if I can find it. On spare space. Yeah. Okay, down here. Okay. So hot spare space, you can see here, if you choose high hot spare space, for every 12 disks, you'll have one hot spare. So 12, 25, 50, all this stuff, you'll have more hot spare. But if you choose low hot spare, basically until about, okay, they increase the size to 25. So basically until 25 disks, you'll have one hot spare disk. So you only get a choice of either low or high, right? Okay, so you choose either low or high. Low meaning you'll have one hot spare disk for every 25 disks, right? And yeah, it's not actually 25, but yeah, plus minus, that's how it works initially. So it's a bit wonky in this sense, right? So if you're on high hot spare, basically for every plus minus 15, 20 disks, you will have one hot spare, okay? So this just keeps going on and on. If you have more and more disks, this is the maximum limit for Huawei. Usually you'll have about 375 disks, which includes, if you're using Huawei, it's about 5 disk arrays, right? Plus minus, okay? So if you're using about 5 disk arrays, then you can achieve this 375 disks. And then you'll have maximum, if you use high, you'll have 8 hot spare. If you use low, you'll have 4 hot spare disks. And that's how it works. You just choose high or low, nothing else, okay? Then the disk domain itself. So the disk domain, you have all your physical disks. You want to create a disk domain with certain tiers of disks or certain types of disks or all the types of disks, up to you. You can choose the number of disks you want to put in a disk domain, okay? So you choose the number. So you want to have 1 disk, 2 disks, 10 disks, and all this stuff. It's up to you. Make sense? So here in Huawei Ray 2.0 Plus, they have disks. They categorize into different tiers of storage, which is basically high performance tier, performance and capacity. High performance tier is SSDs. Performance tier is SAS disks. And capacity tier is NL SAS disks. Okay. So that's the difference here. So you can choose how many disks you want to put into your disk domain. They will allow you to choose the number. So when you're creating a DD or disk domain, they'll say, okay, how many SAS disks you want to put inside? How many NL SAS disks? How many SSDs? You can choose the number. Later, when we do the simulation, you'll get a much more better picture. That's why I would rather do the simulation. But yeah, when we do the demo and all this stuff, definitely you'll get a better picture of how this works, right? If you just understand in theory, you have to kind of see it in real life, right? So that is a disk domain concept. Then you have the storage pool and tier, of course. So storage pool is basically a virtualized environment after you create a disk domain. So when you create a storage pool, they will ask you to assign a RAID policy, right? So the RAID policy is basically, these are the RAID policies. So I think this has been updated. This has changed somewhat. Like Huawei, OceanStar, Dorado has RAID TP and all this stuff. So yeah, that's different. But if for your hybrid storages, you have RAID 1, RAID 1.0, RAID 3, RAID 5, RAID 5.0, and RAID 6, right? They don't have a RAID 0. Huawei does not use a RAID 0, but RAID 0 is something that we have to learn about. So these are all the RAID policies you have. Depending on which kind of RAID policy you want to use, basically, the amount of disk space is then available there. So if you say you have 50 terabytes of storage space, or let's say just 10 terabytes, and you have about 10 disks, right? And then you're going to use RAID 1. So basically you'll have 5, and basically you'll have 5 terabytes of storage space, okay? If you use RAID 1. If you use RAID 1.0, then you calculate that way. If you use RAID 3, RAID 5, RAID 5.0, and RAID 6, the calculation will be done. However, you don't have to worry. All this is automatically calculated for you, right? So you don't have to do a manual calculation of how much storage space you have and all this. The moment you choose your RAID group, they will already, before you select it, they already tell you okay, this is how much disk space you'll have after you choose this RAID group. So you get to choose whichever RAID group you want, right? These are all the choices. Then disks are put into storage tiers. So yeah, high performance tier SSDs, performance tier SAS, and capacity tier NL SAS. SSDs are what they call for hot data that is being used frequently. SAS will be called warm data. This is another storage basically concept, right? And capacity tier will be called cold data, right? So you'll save data into different tiers of storage. Later, when we enter the advanced storage technologies, you'll understand why they call hot, warm, and cold. But for now, just yeah. And this is storage pool and tier. Okay. Disk groups, yeah, in the disk domain, nothing much. You either got a SAS, NL SAS, or SSD disks. That's the disk types, right? Logical drive basically is basically creating a logical version of your disk. So when you attach it to a disk domain, they already create the logical drive for you. Chunks. So chunk is the disk space of a specified size allocated from a storage pool. It is the basic unit of a RAID array. So things you need to remember, once again, 64 MB. By default, you cannot change this size. A chunk is always 64 MB. Doesn't matter what disk it comes on, it's always 64 MB in size. Chunk groups, basically from previously we saw multiple chunks from multiple different disks, will then create a chunk group, like this picture here. Okay, so you have disk 1, disk 2, and disk 3. So the chunk from this 1, the chunk from disk 2 and disk 3, so 1, 2, and 3 will create your chunk group. Okay, from your disk domain, right? This is where basically you attach, in the chunk group is where you attach your RAID policy, right? So this is done on the storage pool level. Why I keep talking about storage pool level, so is when you're creating the storage pool, they'll ask you to put in your RAIDs. So actual backend is when you're creating, when they are distributing the chunk groups, actual backend. But for us, when we are creating the storage pool is when we attach our RAID policies. That's it. Okay. So basically all these chunks are 64 MB in size. They will be added together to create a chunk group. Once the chunk group is created, you then, if you want to provide storage space to customers or storage space to servers and all that, they will further break it down into extents. So what happens here, they will like chop these guys in half, and that will be one extent. Okay, make sense? So if you have like about 6 extents coming out from the same group, so they just keep chopping the guys, chopping until you get 6 extents, right? So they will be from different disks. Not only that, basically the different chunk groups and all these things. So it starts getting complicated there, but if you understand the concept, easy. So they'll create like from, yeah, go ahead, sir.
Sorry, Mr. Previn. You said that before chunk, the maximum size of chunk is 64 MB, right?
Yes, default size of chunk is 64 MB.
Yeah. What about chunk group? Can you go back to the previous slide?
Yeah, sure. No. Yeah. Okay.
So if there are three chunks in this picture,
yep.
So the chunk group size is 64 times 3 or
yeah, 64 times 3.
Yeah. Oh, yeah. Okay.
Yeah. So depending on how many chunks you have in a chunk group, that's the each chunk is 64 MB. So just times that many chunks. This okay. I don't know what's the actual size of a chunk group because it depends on how many disks you have.
Okay. Yeah. And another one related to RAID policy. on the practice or on the best practice, we have to manually configure or how to decide which one is our rate policy.
When you're creating your storage pool in Huawei storage, right? Basically, they will have an option. So they'll just have a small option here. It's a drop-down menu. So you get a drop-down icon here. And they'll say, okay, what rate policy you want to choose? So you just drop down, choose which rate policy you want. Does that make sense, sir? So whatever you will see is GUI. Everything you'll be seeing is GUI. You won't be seeing the CLI.
Okay.
Yeah, it's all done in GUI mode. But its actual sense is when you're creating the rate policy is when you're creating the chunk group and stuff. It's something that we don't see, but this is how the technology works. You will just say, okay, create this domain, create storage pool, create LAN, right? That is from our perspective as a storage administrator. But this is the back-end process.
Okay, which rate policy that you suggest for configure the?
Well, that is depending on application. Man. I cannot.
Okay.
It's all depending.
Yeah, depend on this.
So it's depending on you. I mean, you as the So I can't tell you what's the best rate. There's no best rate group. I mean, different rate groups give different kinds of things, right?
Yeah. Right. So it's depend on the application, right?
Most likely depend on.
Yeah. Yes. Okay. Thank you.
No worries anytime, sir. Okay, then extends. Once again, what we need to know from extends: default size 4 MB, maximum size 64, and minimum size 512 KB. Why? You'll use this for database, most likely, but I don't think they go until 512 if you want to. Usually people go the one bigger than 512 and stuff, or like 1 MB or something. 64 MB you'll use like for your videos. And generally, if you don't know what to use, just use 4 MB, right? By default. So multiple extends from multiple chunk groups will create your LAN, right? So you'll see here, they simply add this thing to make, later on, we'll talk about something called thin LAN and thick LAN. But for thick LAN, they'll just use extends. So your extends will become thick LANs, right? So thin LANs and thick LANs later we'll talk about. So for thin LANs, they will use something called grain. Grains are 64 KB in size. If they ever ask the question, you just need to know grains are 64 KB in size. By default, you cannot change the grain size. Grains are actually smaller extents. So they take the extent and then they break it down again into grains. This technology is only used when you create a thin LAN. So we'll talk about thin LANs later when we go into chapter 3. You'll get a better understanding then. But just know there is a concept called grain after extend, but it's only used in one sequence, whereby when you're creating thin LANs, right? So previously you saw thick LANs. Thick LANs, they use extend. Thin LANs, they use grains. Okay. So this is a fixed size, 64 KB by default. Volume and LAN. So volume is the internal management of a storage system. So we call whatever size of space you have inside your LAN inside your or can't say it LAN. So whatever storage space that you want to provide to the customer inside your storage environment is called a volume. When you provide it to a server, it's called a LAN, logical unit number, right? But if it's still inside your storage space, it's called volume. It's actually the same thing, right? So LUN is the virtual representation of a server of a storage space. Inside your storage environment, it's called a volume. That's it. So basically, LUNs are mapped to hosts. Volumes are what you find inside your storage. Okay, and that is RAID 2. Yeah, go.
So basically, volume and LAN is the same, just the name where it plays.
Yeah.
Like that?
Yeah, depending on where it is. So if it's inside your storage, it's called volume. If it's given to a server, it's called a LAN. That's all.
Okay.
Okay. So we'll just go into the other RAID technologies and we'll take a break. So I don't think there's that many. Yeah, it's just 2 slides. So what's the time now? Oh, yeah, RAID 2.0 plus does take some time. Right, so we'll talk about other RAID technologies. So Huawei uses what they call a dynamic RAID algorithm. This is how you do your multiple, your multiple chunks and all that are used in the dynamic RAID algorithm. How they do the RAID reconstruct. You don't have to spend too much time here. As long as you understand how the RAID reconstruct happens, the many to many and the many to one, then you're good, right? So you don't have to spend too much time here. Generally, they won't ask questions regarding Huawei's dynamic RAID. However, the next one, RAID TP is only found on OceanStor Dorado, right? So currently only OceanStor Dorado. And if I'm not mistaken, they also Dorado V6, right? Only in OceanStor Dorado V6, you'll find RAID TP. RAID TP is a technology that Huawei has created for triple parity, right? So RAID TP basically means you can have up to 3 disks fail in the RAID TP group, and the system can still keep running, right? So minimum disk in a RAID TP group, you will have to have a minimum of 6 disks, right? Minimum of 6 disks. How RAID TP works and all that, we don't know, because that is something that Huawei, it's proprietary Huawei technology. They don't tell us how it works. So yeah, I mean, I don't know how it works, but yeah, I've tried to read documentations. I cannot find the algorithm and stuff. But RAID TP basically, with Huawei OceanStor Dorado, greatly reduces the reconstruction time. It works very well together with also RAID 2.0 plus, right? And that's it. Okay, you just need to know RAID TP triple parity. 3 disks can fail, your RAID groups can still work, no issues. Okay, so some questions here you will go through. If you want to answer them, go ahead. I will just go through the summary. So in summary, we have gone through the RAID technology. So we went through traditional RAID, which is RAID 0, RAID 1, RAID 3, RAID 5, and RAID 6. And then we also went through the nested RAID technologies, which is RAID 1.0 and RAID 5.0. We talked about RAID 2.0 plus. And then we talked about RAID, dynamic RAID and RAID TP in some sense. Don't focus too much on dynamic RAID and RAID TP. Spend most of your time on RAID 2.0 plus. Okay, for more information, you can find them here. Some recommendations here. And thank you. So that is RAIDs. So before we close off the subject, any questions?
Question, sir.
Yeah, go
About
ahead.
RAID 2.0 plus is mandatory from Huawei, where we can find the information in the future when we have a problem, we have question. And is any other vendor or is any other what the name is have the same like RAID 2.0 plus?
Yeah, so block virtualization is what they call the technology. So
Okay.
I think like Huawei RAID 2.0 is Huawei's RAID 2.0, I mean Huawei's block virtualization technology. There will be other vendors like I think HP has one.
Okay, so the key point is block virtualization, yeah.
Yes, the technology is called block virtualization. It is actually created by some students in a University of California, right? So then most vendors are using it, but generally it's just a technology theory, and people like Huawei, IBM, HP, and all these guys have taken this technology, NetApp even taken this technology and then created their own. But I think in the market, Huawei is the one with the smallest chunk size, right? So other guys' chunk size will be about 128 MB, right? Huawei is the only one that uses 64 MB, I think, if I'm not mistaken. So a bit smaller in chunk size. If you want to read anything about RAID 2.0 Plus, I would suggest you download this tool. It's called HeadX, right? So you download this HeadX Lite. I'll give you the link here. It's a free tool, right? So that's the link. So you can download this tool, and from this tool, it works like a messenger tool. So let's see if I can open HeadX Lite here. HeadX. Okay. Oh, I deleted it or something. Do I have the HeadX Lite? I know I had it somewhere. Maybe I went through some reformatting process here and there and stuff. But basically, you can download this guy. Once you download this guy, it acts like what do you call this? A white paper library. You can download any white papers for free from Huawei, right? You don't have to pay any money for this HeadX Lite stuff. Or you can just go to support.huawei.com, like here, and just put in, you're going to search for RAID 2.0 Plus. And they will have the documentation. I think it's this one. Yeah. So RAID 2.0 Plus. Okay, so you go here, learn more. Amen. I agree. Yeah. You can ask this guy about RAID 2.0 Plus, right? Do they have multimedia? Yeah. Okay, using smart gear, virtualization, yeah. So this is created by some guy called Nizam. Cool. So you can go, usually they have it a lot in their forums. You can find a lot of white papers around it. If you just go to Google and type in RAID 2.0 Plus, you can find it somewhere here. Okay. So you have a lot of documentation on RAID 2.0 Plus, so you don't have to worry about something going wrong with RAID 2.0 Plus. By default, when you buy a Huawei storage, it is already included, right? As long as you buy any Huawei Ocean Source storage, the default block virtualization technology is always used. You don't get a choice in that some sense, right? So you can see here it's proposed by University of California, Berkeley, and all this stuff. So it's not a new technology. It's just that Huawei's version is a lot more faster. That's why they're very compatible in the market. Does that make sense, sir?
Okay, thank you, sir.
No issues, no issues. So let's close this. Oh, my storages are still open. All right. So there's no more questions. We will cut to a short break. Okay. So I know I have been talking for a long time, so I'll give a bit longer break.
I have a little question.
Sorry, sir?
I want to ask any question.
Yeah, go ahead.
What implementation of the RAID 2 Plus? It's only implemented in internal server or also in the storage server?
It's only implemented on the storage controller. So it's only on Ocean Source storage. So it doesn't matter what LAN they provide to the server. Basically, the backend RAID 2.0 Plus is already working. Does that make sense, sir?
Okay.
Yeah. Any other questions? Cool. No worries.
Mr. Prevan, I'm sorry, I will flashback a little bit more.
No worries. No worries.
It's related to green, you said that green is the smaller version of X10, right?
Yes.
So this the default size is 64 KB.
Yes.
Yeah. Is there a maximum size or
No,
just
it's only one
the
size.
default? Oh, it's only one size.
Yeah. Fixed size 64 KB.
Okay.
No issues, no issues.
Yeah. Okay.
Right. So we will talk about grains when we talk about thin LANs later on.
Okay. Thank you.
No issues. All right. So I know I have taken up a lot of your time. So what we'll do is we'll give you guys a 20-minute break. So currently the time is 10:35 for you guys, right? So basically we'll come back 20 minutes later. So we'll come back at 10:55. Okay. So just take a longer break, no issues, and then we'll continue on with the next topic. Okay.
Okay.
All right. Yeah.
Okay. All right, guys, we are back. So that was module 2, chapter 2. Okay, so we'll continue on with module 2, chapter 3. This is one of the, well, longest chapters we have. I would say this chapter is also where most of the technologies will be brought out. But don't worry, we only have to understand it on a high level. We don't have to really go into the technologies. So I won't explain that detail deep in down and all this stuff. Just take it on a high level and should be fine. Okay. So module 2, chapter 3 is what they call common storage protocol. So this is where we'll learn all the different types of protocol or protocols used in the storage system. So a protocol is a set of conventions that both communication computers must comply with. For example, how to set up connection, how to identify each other. A protocol not only defines the language used for communication, but also specifies the hardware, transmission medium, transmission protocol, interface technology, and so forth. This course describes the definitions and principles of different storage protocols. So the objective of this topic is to learn more about common storage protocols used in storage systems, understand the working principles and features of these protocols themselves. So content-wise, we have 6 things to go through. So we'll go through the basic protocol, which is called Scuzzy, or the earliest protocol in some sense. Then we'll go through Scuzzy, Fibre Channel, and Fibre Channel over Ethernet. Then we'll go through SAS, or Serial Attached Scuzzy, and SATA, Serial ATA. Then we'll have a small look at HCIA and NVMe. Then we'll take a look at RDMA and InfiniBand, and finally CIFS, NFS, and NDMP. So when we reach all these topics, don't worry, I will tell you guys the abbreviations and stuff. Okay, so we'll start off with one of the most familiar protocols in storage, Scuzzy. So Scuzzy, which is termed by storage guys in this sense, right? It's actually called SCSI, which is Small Computer Systems Interface. But yeah, storage engineers will just call it Scuzzy, and all this stuff, right? This is basically a base protocol used in most storage environments, right? Even though you still see them using like Fibre Channel and all that stuff, but a protocol set actually being used is a Scuzzy protocol set, right? So the Scuzzy protocol defines a model and a necessary set of instructions for different devices to exchange information using the framework. The Scuzzy protocol is irrelevant to transmission media, so it transcends transmission media in some sense. So it can be implemented on various media and eventual virtual media. So Scuzzy as a protocol or Scuzzy as a connection you will not see, but Scuzzy as a protocol you will still see used in the storage environment. So Scuzzy's protocol is always 3 sets, which is a system, a Scuzzy device instruction set, system model, and link implementation. It will always be this way, okay? So you have to just remember these 3 things. You don't have to remember the SPC and SSC and all this stuff. What you have to remember is you got Scuzzy instruction set, system model, and link implementation, right? For both target and initiator, it will still look the same. Don't worry. Scuzzy has gone through also 3 iterations. So the earliest one was Scuzzy 1, then Scuzzy 2, and Scuzzy 3. Now Scuzzy is not being developed anymore because it's already reached its eventual, let's say, highest technology level. There are, however, other protocols, there are plans for other protocols to take place of Scuzzy, right? So that is Scuzzy itself. You just have to remember the three things: device instruction set, system model, and link implementation. It will always be the same. So we talk about Scuzzy evolution. So Scuzzy was launched in 1983. It was eventually given up around 1985, right? They did not improve on Scuzzy after 1985, whereby Scuzzy 2 came into contents around 1988. It was used until 1984. And then you have Scuzzy 3, which is standardized in 1993. Okay, so Scuzzy supports both synchronous and asynchronous, but only 8-bit devices for Scuzzy 1. Okay, for Scuzzy 2, you have 16-bit devices, and for Scuzzy 3, it became like the main protocol to use. It is always backwards compatible, so no worries there. The problem with Scuzzy 1 was the pins, right? So you have different kinds of pins and all this for cable types and all this stuff. Okay, and the maximum bandwidth is around only around 5 megabytes, right? And it can only span about 6 meters the most. So you want to do a connection, 6 meters is the max. Then you have Scuzzy 2, which supports more about 20 megabytes. And it supports 16-bit bandwidth cables, right? Then Scuzzy 3, yes, it has evolved further. It also has been included in Fibre Channel protocol. So if you see Fibre Channel protocol being used, the actual protocol inside the fiber is Scuzzy, right? So how does Scuzzy work? Scuzzy works in what they call the client-server model, right? So there'll always be an initiator. So you see this word here, and there'll always be a target, right? So the initiator will initiate something, will send the initiating information to the target, and the target will do something and reply back to the initiator. So in more sense, how it works, the initiator is always the server. The target is always the storage controller, right? Usually. So usually it will always remain this way. The initiator always being the server and the target always being the storage controller. Only in one instance, there is only one time or a certain, basically if something happens, but there's only one time where the initiator will be the storage and the target will be the server. The only time that happens is during restoration, right? Backup and restoration. So backup, yes, server initiates the backup, storage keeps the backup data, but only during restoration, if something goes wrong with the server data and all that, so you want to restore the data, that is the only time that the storage system becomes the initiator. So in most sense, it's always the server being the initiator, initiating the traffic towards the storage. Make sense? So this is how it always works, right? Generally. So the server will initiate some kind of traffic. The traffic will be sent via some kind of link towards the target. The target will then say, okay, so your LAN is whichever LAN. So I'll provide it to you. You can change your data inside your LAN and all this stuff. And that's how it works. It's always what they call the client-server model. Here they just call it the initiator target model, right? Simple. If you understand how client-server model works, yeah, it's exactly the same, right?
So it's like authentication.
You can't say authentication. Well, not really much authentication, just like instructions. The client will always instruct the server to do something. Make sense?
Like server say, I want to use that LUN, like that?
So server will say, I want to use the LAN to save this data. Then the storage system is like, okay, this is your LAN, save your data.
Okay.
So it's always the client initiating something for the server. The server will then the client will initiate something for the storage in this sense. And then the storage replies, okay, what do you want to do? So it'll open up its storage system, give you the space and all this stuff. Generally, the space provided by the storage in this sense is always a LUN, a logical unit number. So the LUN is after you do your RAID 2.0 plus and all these things, you get the LUN. That LUN will be then provided or mapped to the server. So that LUN will belong to the server itself, unless you remove the LUN, of course. Okay. So this is what, so you remember the three models, right? Device instruction set, system model, and link implementation. However, they have a target model and initiator model and a target model. So initiator model basically starts from your device driver. So whatever server devices you're using. The middle layer is basically what they call the compatibility layer or something like that, right? So basically, the middle layer, So the middle layer is where all your Scuzzy device sets and all that go into. And finally, you have the link layer, which is basically sending the information out. Okay. So the device drive layer is basically what kind of devices you're using. So like here, you can say like Windows, Linux, AX, Solaris, and all this stuff. The middle layer is where how they build the protocol architecture. And the link layer is how they send the protocol out. This is how the initiator model looks like. The target model will be basically starting, if you just flip it upside down. So you just say start from the port, then you go to the middle, and then you go to the device layer, right? So traffic is actually moving this way, right? So traffic is coming from the server, coming into the port layer, going into the middle layer, and then going to the device drive layer, right? So the most important layer in most of the Scuzzy commands is always the middle layer. This guy is the one that maintains the Scuzzy architecture. Okay, maintains, just type it out properly. Yeah. So this is the guy that maintains the Scuzzy architecture, like namespace, links, target devices, tasks, task sets, sessions, what is happening and all that. It's all done in the middle layer. The device layer is just how to talk to the device. So like what kind of device you're talking to, what kind of storage you're talking to, SAN storage, NAS storage, right? So that's how Scuzzy works, right? So target layer is basically talking about the storage end in most cases. The initiator model is talking about the server. So how the server initiates traffic. So the server will say, okay, from my IBM device or some kind of Windows IBM device, how I want to send the protocol out. So what kind of tasks I want to do and all that stuff, that will be done by the middle layer. What is the architecture of the protocol? And then send it out to the link, right? Once it's sent out, it will then reach the target. So the target will receive the traffic via its port, and then it will determine the architecture using the middle layer. So what it wants to do, what does the server want to do, and all these things, and finally send it to the disks in most sense device layer, right? Make sense? So that's how it works. So you don't have to kind of understand, okay, what are the actual protocols, how is the actual architecture and all this stuff. No, you just have to remember port, middle, and device for target, device, middle, and link for initiator. If you remember these two things, exam, they will mostly ask those questions only, okay? Then you have to understand how the protocol actually works. So the protocol Scuzzy uses a bus architecture. So it's like a bus. Problem with bus architecture is this, right? So when this Scuzzy, let's say this is controller 0, and this is controller 1, right? So when controller 0 is talking, controller 1 cannot use this link, right? Because controller 0 is talking, so he will send his information to the maybe the device and all this stuff. Have you seen a Scuzzy cable before? Most likely, if like from the 90s or maybe the 1990 up to about 1993, you might have seen a Scuzzy cable in your PC before, right? So let's just show you. Most likely you've seen something like this before. Like you'll have one cable coming out from your PC, you connect to one disk, then the cable connect to the second disk, it's all one cable, right? You'll have multiple cables connected to a disk here and there. So it looks something like this, right? Have you seen this cable before? No? Maybe some of you have, some of you have not. Right? If you're older generation, you will understand this is how the cable used to work in your old PCs and stuff. So you'll have like from the server, you'll have like okay, add it to the disk drive, your cable go through the hard disk and then attach to another hard disk, and then finally you'll have a terminator or Scuzzy terminator. Yep. So it looks something like this. You'll see just some random plug at the end, right? That is what they call a terminator. Something like this. Most likely it looks like this, right? So these are old Scuzzy products. The terminology used for Scuzzy is what they call a daisy chain. Why they call it a daisy chain? If you go and search for just daisy chain, basically it's this stuff, flowers. So you make a chain of flowers, a chain of daisies. Somebody invented this kind of daisy thing. Maybe it's a old days hippie stuff, but nobody knows. But basically Scuzzy works the same. All the devices must be connected in a chain, right? So that's how Scuzzy works. You'll see there, daisy chain, chaining the cable. Same thing with Scuzzy. You'll have a chain of devices, right? And then at the end, you will have something called a terminator to terminate your Scuzzy device. So that's how it works. The problem is because it uses bus technology, but they have implemented sessions on bus, so don't worry about that yet. So the bus technology is, if I'm using the bus, so if I'm using, let's say you have 1, 2, 3, 4, many buses here. So let's say I'm using bus 1. So I'm trying to send information via bus 1 to maybe this guy, right? So when I'm using the bus, nobody else can use the bus. Until my traffic goes through, then you can use the bus for bus 1. Of course, you still have bus 2, bus 3, bus 4, bus 5, and bus 6. So depending on which bus you're using at the time, so here you have 1, 2, 3, 4, and so forth. So let's just say 1, 2. So let's say this controller is using Scuzzy ID bus 1. So if I'm using bus 1, at the time when I'm using bus 1, nobody else or no other device can use bus 1. So if this guy wants to, like Scuzzy ID array is 5 here, once you send some information, he might have to send it via bus 2. He cannot send it via bus 1. Why? Because currently Scuzzy ID array 0 is using bus 1. So this is where they create multiple sessions, right? So you have multiple buses where you can send multiple information at the same time. However, there are limited amount of buses, right? So you only have a fixed amount of buses. So if all the buses are being used for sending or retrieving data or something like that, you have to wait for the transmission to complete and then you can continue. This is a problem with Scuzzy, okay? And to understand Scuzzy, Scuzzy uses IDs. So you remember when we talk about the disk array or we talk about the storage controller, there will always be an ID at the side here. So like 0, 1 or something, right? There will be a digital ID. That ID is still, that concept is still being used for Scuzzy, right? So each device will have its own unique identifier. So the host adapter, like this is the server. let's just say this is a server. Okay, so the server has an ID of 7. The Scuzzy array has an ID of 0. The controller 1, controller 2 has an ID of 5, right? So everybody must have a different ID. And if you remember earlier, they said Scuzzy, for Scuzzy 1, you have 8-bit devices. So you can have maximum, I think, 8 devices connected in the Scuzzy. 16-bit, you can have about maximum 16 devices connected in the Scuzzy chain. 8-bit, 8 buses in that sense. 16-bit, you have 16 buses and all this stuff. Generally, it's the technology is still being used, protocol, but the connection method is not being used anymore because it was a very, very tedious or troublesome method whereby you have different kinds of cables, you have limited distances, all these things, right? But main thing you need to understand is each Scuzzy device must have its own unique identifier. That's why if you look at all hard disks, maybe you can search for all hard disks. Maybe you still can find it, right? Yeah. Oh, Scuzzy hard disk. Okay. So last time when you have like Scuzzy hard disk and all that stuff, you will see this small thing at the side here. Sometimes you'll add pins inside, right? So each pin, like you'll block something with a stopper and all these things. So each pin represents a different number. Okay, so maybe it should be something like that, right? I forgot what's the name, what it's called. But basically you will add a pin. So if you like add a pin like here in this sense, so you will just block these 2 pins and that will be like Scuzzy ID 1. If you block like 4 pins, it'll be like Scuzzy ID 2. If you block like something like this, it'll be like Scuzzy ID 3 and so forth. So there's a limited number of Scuzzy ID in the old technology, right? And that's how Scuzzy works. So each device will have to have its own unique identifier. If they have the same ID, so like even if this guy is a Scuzzy ID 7, they cannot send traffic to each other. Basically, a Scuzzy chain breaks. They must have a different ID. And when somebody is talking, so like when the server is talking, the bus is used up. You have, of course, different buses to use. So if all the buses are used, basically the Scuzzy, you have to wait for all the traffic to go through. Then you can start using the bus. Okay. Any questions so far? So you need to understand the bus technology and you need to understand the Scuzzy ID. Okay. So Scuzzy protocol addressing. First, you have your bus number. So bus number 1, bus number 2, all the way up to bus number 16. And then you have your device ID or Scuzzy device ID. So device 01, all the way up to device 16 and all this stuff, right? And then finally your LAN. So your LAN will also have a unique identifier. So when you're trying to save some data and all that, they'll use the unique identifier of the LAN with the device ID and the bus number to send the traffic. So first they will check the bus number. So like, okay, which bus am I using? Which device am I going to talk to? So I'm going to talk to Scuzzy ID 7. And then what is the LAN that I'm going to use to talk to the Scuzzy ID 7 device, right? So this is the protocol addressing. Bus number, device ID, logical unit number, or LAN, right? These 3 things must be there for you to achieve connection or interconnection between storage and server, or server and storage, right? So that's how Scuzzy protocol addressing works. It's not a hard concept, but you just have to remember the names and stuff. Bus number, device ID, logical unit number, how the Scuzzy bus works, and so forth. Okay? And that is Scuzzy. So sure you guys got no questions? Cool. Right. Then we talk about Scuzzy, Fibre Channel, and Fibre Channel over Ethernet. So Fibre Channel will be a very, let's say, in-depth protocol. So we'll first start with Scuzzy. So why did Scuzzy emerge? Basically, small computer systems interface, you only have a limited number of devices. So theoretically, if you use your IP network, you can establish connections to unlimited number of devices. So about 60 million, 600 million plus devices because of how IP address works, right? So using the concept, they built something called Scuzzy. Scuzzy is basically, the term is Internet Small Computer Systems Interface, right? Just the extra part is the internet part here, right? Other than that, it's still running on Scuzzy commands, but this command or this protocol runs on IP-based networks, packets, right? So that means if it runs on packets, it's something that you can detect. Scuzzy commands, you basically only server and storage talk to each other. It's something that you cannot use like a packet tracer or something like that. Scuzzy, however, you can use a packet tracer. You can find out how the command looks like, what is inside and stuff. So it's not as secure as Scuzzy, some people say. I would believe so also. Okay. So to connect much more devices, they came up with a protocol called Scuzzy, which is based on IP networks, right? So Scuzzy command structure. So you still have what we call the Scuzzy command distributor block, right? So Scuzzy commands. So there's Scuzzy applications like file system, database, there are Scuzzy instruction blocks, Scuzzy flow instructions, Scuzzy other instructions of Scuzzy. You still have your Scuzzy commands, right? All these things basically come up to what they call Scuzzy CDB, command distributor block, right? So CDB of Scuzzy is still there. However, it then encapsulates it into something called an Scuzzy PDU. PDU is protocol data unit. Right? So you encapsulate it into Scuzzy PDU, then you encapsulate the Scuzzy PDU further into TCP IP packets, right? TCP, right? TCP and then IP, finally Internet Protocol, right? So it is being encapsulated into multiple different types of packets before being sent out over the Ethernet link. Why Ethernet link? So basically, if you're using IP packets, the connection type is Ethernet, right? So this is where we can use our Ethernet switches. Else, if you just use Scuzzy, you might have to use Fibre Channel. But if you want to use Scuzzy, then you can use your normal Ethernet switches and stuff, right? So this is what they call the encapsulation process. I know, boring topic. Yeah, we have to learn about it, what to do, right? So basically, you encapsulate your Scuzzy commands into what they call an Scuzzy PDU, protocol data unit. After it's encapsulated into Scuzzy PDU, it's further encapsulated into a TCP IP packet, right? So once TCP IP encapsulation is achieved, then you send it into Ethernet frames and send it over the network, right? So this is the full Scuzzy instruction, or let's say Scuzzy protocol instruction set, right? Starting from Scuzzy, you encapsulate into Scuzzy, then you encapsulate to TCP, then you encapsulate into IP, and then finally Ethernet, and send over the Ethernet link as an Ethernet frame, right? The same thing will go on the other end. So when you receive the information, you have to decapsulate into IP packets, decapsulate into TCP, Scuzzy PDU, and then finally Scuzzy packets, right? So this is how it always works. You must remember the commands, right? You must remember Scuzzy PDUs, must remember after Scuzzy PDUs, we encapsulate to TCP IP packets, and then finally send over Ethernet link, right? Main thing here, Ethernet. It is using Ethernet connection. Any questions so far? So this part don't really have to remember, but you have to remember the encapsulation part, right? You have to remember the encapsulation at least, how the protocol works on a high level. Who?
Mr. Prevan, before PDU, you said before that there are CDB, right? For
CDB, command distributor. Yeah.
Okay. Command. What is the?
It'll be like command. Something like that. My spelling might be wrong, but yeah. Basically, it's Scuzzy command block, right? Command distributor block. My spelling might be a bit wrong, but yeah. Basically, it looks like that. Make sense, sir?
Yes. Thank you.
No worries. Then finally send over the Ethernet, and then you get your Scuzzy PDU. Okay. So initiator and target still follows the same concept. So only difference here is basically, yeah, see, command descriptor block. Sorry, I always come distributor. I don't know why. So command descriptor blocks. So this is a term. So you'll get your Scuzzy CDBs. You'll then encapsulate it into Scuzzy PDUs, encapsulate it into TCP IP packets, and then send it over the Ethernet link. Once it's the Ethernet link, then you have the Ethernet frame and all that stuff. Once it reaches its target, it will then be decapsulated, right? So it's always encapsulate, decapsulate. Right? So it's like encryption, decryption. So basically here is like the encryption part, and then when you send it over the other side, they have to decrypt the command, and then you can get the free commands, right? So in these terms, we call it encapsulate, decapsulate. So yeah, okay. So the initiator, the Scuzzy layer generates the command descriptor block and transfers them to the Scuzzy layer. The Scuzzy layer generates Scuzzy PDUs or protocol data units and sends them over the IP network, right? The target will then receive the IP packet or the Ethernet frame and all the stuff, and then it will do the decapsulation, right? So it will receive the Scuzzy layer, receives the PDUs, sends the CDBs to the Scuzzy layer. The Scuzzy layer interprets CDBs and gives the responses when necessary, right? So this is how it still works as initiator target model. It's just that you have extra layers of protocols. Scuzzy and Scuzzy, if you're just talking to Scuzzy, you basically don't have to go through this whole thing. But if you want to use Scuzzy, you have to add this whole thing. Scuzzy is just send the command distributor block from the target model to the initiator model. But if you're using Scuzzy, you have to change it to Scuzzy protocol data units, change it to TCP IP, send it over the Ethernet link, and then so forth, right? So this is how Scuzzy works in general, from server or initiator to target storage, right? Cool. So Scuzzy architecture, very simple. It uses the IP network, right? So you can see Scuzzy nodes encapsulates Scuzzy instructions and Scuzzy and data into Scuzzy packets and sends these packets over the TCP IP layer, where the packets are encapsulated into IP packets to be transmitted over the IP network. So because they use IP addressing, any network engineer can configure the IP network for this guy. You'll still be using the VLAN based stuff and all this stuff, right? So here is an Scuzzy initiator. You have the initiator sending this basically like the command distributor block. Then it'll be changed into Scuzzy PDUs, then changed into the IP address. sent over the IP network. Once they receive it, the storage receives this IP packet. It will then do the decapsulation and send it back to the target as a CDB. So the end game is to reach the CDB, command descriptor block, right? Sorry, I keep coming out with distributor, I don't know why. Okay, and that's how it works. So if you take this theory, so let's show you this one, right? So if you understand this theory, if you want to see it how it looks like in real life, I have a link here for Skazi, so you can see this is what they call Cloud Shark. It's an online packet tracer. If you're familiar with Wireshark, this is how it looks like. So in Wireshark, you can basically do packet tracing or packet capturing on each packet that goes through the link. So you'll see here how the protocol looks like. So you start from the bottom, you have your Scuzzy, right? And then you have your Scuzzy packet, right? So it's encapsulated in the Scuzzy PDU. So this is your Scuzzy commands, right? These are your Scuzzy stuff. Encapsulated into Scuzzy PDU. Once it's encapsulated into Scuzzy PDU, they send it over TCP. So TCP source destination port is needed. So which source port is coming from, going to which destination port. Once that is done, it's then further encapsulated into a IP packet. So using some kind of source IP address and destination IP address. And finally send over the Ethernet frame. So this is exactly how the packet works. Once it's sent to the other end, so this is, I think, the response, right? So same thing. Well, once it's sent to the other end, you get the IP packet. So they'll check, okay, the source address is from where, destination address is from where is he planning to go to, what is the IP address, what is the protocol, what is the TCP segments, what is the Scuzzy packet, so Scuzzy PDU, and finally, what is the Scuzzy command. Scuzzy commands you will not see much. You'll just get a LUN number and what is the status. But in actual fact, there are a lot of other instructions inside, but you can't see, right? Packet tracing, you can only see these things. But already with these things, you can already know, okay, yeah, what is happening, right? So this is how a Scuzzy packet looks like. You'll have all these layers, the Ethernet frame, the IP address, the TCP packet, the Scuzzy PDU, and finally the Scuzzy command itself. So you see the LUN here. This is a LUN number for some set. Okay. So that's just to show you how it actually looks like in real environment. Exactly the same as what they talked in the slides. Okay. So the initiator will start the initiation on the CDB, send it to the Scuzzy PDU. Once the Scuzzy PDU is generated, it will then send it to the TCP IP protocol stack. Then you'll send it to the NIC or the link driver, where they will do encoding. So the encoding method is always 8. You'll see Scuzzy uses 8/10 bit. What does this mean? Like, what is 8-bit, 10-bit? What is encoding level, right? So this is a question they can ask you in exam. What it means is simply for 8 bits, for every 8 bits of data, so 1011 1111. So this is the actual data, right? This is actual data. For every 8 bits of data, I will add a start bit and an end bit, right? So when I'm sending this data over, this guy knows, okay, I received 1. This is his start bit. The actual data is 1111 1101. These two is the start bit and end bit. Same in this situation, right? Start bit and end bit. So for every 8 bit of data, I will send 2 extra bits, 1 to start, 1 to end. So when the packet is sent over, they'll know, okay, the traffic is coming in. I'm waiting for the start bit first. So when it starts, then I can accept the traffic. The start bit will tell you how many bits are behind me. So I have 8 bits behind me. You'll wait for all those 8 bits, and then you'll wait for the end. Once the last bit or the end bit is gone through, then you'll close the connection, right? So that's how it sends data. Okay, that is what the encoding and decoding and all this stuff. So this is done via encoding, decoding is done here. Okay, make sense? So that's the 8-bit, 10-bit. People do ask this question. Sometimes it can come up on exam, so I'm just giving you guys a heads up, right? No issues, right? Cool. So still, you have to remember, here is CDB, command descriptor block. Here is Scuzzy PDU. This is TCP IP packet. Then it's, yeah, you do your encoding and basically 8-bit over 10-bit, 8B over 10. And then you send it over the physical link as 101111, right? This is how it always works. So from initiator, it's encapsulation. It's always called encapsulation. So why am I keep talking about it over and over again? Because it always comes out in exam, right? And here it's called decapsulation, right? Decapsulation basically means it comes in through here, you decapsulate into the TCP IP protocol stack, you decapsulate into a Scuzzy PDU, you decapsulate further into a CDB, and finally you have what information you want. So if you look at the process, there's so many encapsulation, you compare with Scuzzy. If you're just talking about Scuzzy itself, all these is not needed, right? All these not needed. You just Scuzzy application protocol, target to initiator, done, right? But if you're using Scuzzy, you have so many different encapsulation and all that stuff. So generally, people would term Scuzzy as a slower protocol. Why? Too much encapsulation, too many encapsulation, but there are advantages because they use IP addressing, hence you can reach the device from anywhere, theoretically. As long as there is a route to the IP address, you can reach the device. So theoretically, you can place the device anywhere and it's much more easier to set up. Plus, you can use back all those Ethernet switches and stuff. You don't have to like, if you're using like Fibre Channel, only Fibre Channel. So if you use Scuzzy, just use back your Ethernet switches. If you have some lying around, no problem. You can just put it into your storage network and keep running. Okay. So that's the relationship between Scuzzy, TCP IP, Scuzzy, and so forth, right? Generally, you're still using Scuzzy commands, just encapsulating it further into IP packets. Right, so then we talk about Fibre Channel. Fibre Channel still uses Scuzzy protocol, right? It's just that it's further encapsulated into something called FCP, Fibre Channel Protocol. So Fibre Channel is referred to as Fibre Protocol or Fibre Channel Protocol, FC Network or FC Interconnection. As Fibre Channel delivers high performance, it is gradually used for front-end hosts to access or to point-to-point or switch-based network. Generally, nowadays, if you want to use Fibre Channel, you always use switch-based Fibre Channel network. You will rarely use point-to-point. There are some situations where you want to use point-to-point, but generally you will use Fibre Channel network or switch-based Fibre Channel network, right? So FC brings the following advantages: scalability, transmission distance, security problem. Fibre Channel cannot be hacked unless you enter the network itself, physically go and plant your device there, right? Even then, you go inside the protocol, there is no packet tracer for Fibre Channel. You will not find any kind of packet tracer for Fibre Channel protocol, right? There are other tools that you can use, but you have to basically go into the switch and you have to understand Fibre Channel commands and all these things. It's generally, yeah, if really somebody wants to destroy the Fibre Channel network, he has to be inside the organization. However, like the previous one, Scuzzy, as long as he provides internet connections, hackers can enter. If they know the IP address, you're basically screwed, right? But for Fibre Channel, that is not the way. They don't use any IDP addresses and all that stuff. What they use is something called worldwide name, right? So you have worldwide node name, worldwide port name, right? So these are the concept is called name. The two things under the concept is worldwide node name, and the other one will be worldwide port name. Okay. So in most sense, sometimes they just call it WWN. If they're just talking about WWN, they're most likely talking about worldwide node name, right? So sometimes, yeah, the technology is called worldwide name, but if they're saying, okay, we are using the WWN for the storage, so they're generally talking about using worldwide node name. If they specifically say we are using the worldwide port name, then there's a different meaning to it. So to enable Fibre Channel, it's a bit different. So how Fibre Channel works? Okay. So each host, each device, like a server, put it in text. Okay, you'll have to buy something called a Fibre Channel HBA, right? If you don't have a Fibre Channel host bus adapter card, you cannot run Fibre Channel. Once you buy a Fibre Channel HBA, the HBA card is like a NIC card, right? So you will establish like a NIC card here, a NIC card here, you have multiple connections. The NIC card will have a worldwide name, right? So the NIC card will come with some kind of like the worldwide name 1, 2, 3, 4, 4, something. It's like a MAC address, right? It's a unique name for that NIC card. So this guy will be like 1, 2, 3, 4. This guy will be like 2, 3, 4, 1, maybe. They'll have a unique identity. So it either can be for each port has a unique identity, or the full card has a unique identity. If the whole card, so the card in total has a unique identity. So let's say this is the card and the 2 ports, right? So the card will have a worldwide name or worldwide node name. So the whole card will have one name. Each port will have a worldwide port name. Does that make sense? So depending on how you want to run your Fibre Channel technology, you'll either use worldwide name or worldwide port name, either one. Worldwide port name will be much more secure, much more harder to let's say, set up. But after setting up, generally it runs perfectly. Okay. Fibre Channel still uses the old Scuzzy technology, which is a client-server environment initiated to target. The only difference is if you're using a Fibre Channel switch network, there will be a Fibre Channel switch in between, right? So the initiator will connect to the Fibre Channel switch. Then the Fibre Channel switch will have another connection to the target storage, same case, right? Fibre Channel is mainly only used for host and storage connections. You will not see Fibre Channel used in the back-end disk enclosures. You will not see Fibre Channel here. You will only see Fibre Channel from host to storage. Okay? And Fibre Channel is what they call a lossless network. It can run up to 16. Current situation in Huawei is about 16 to 32 gigabytes, right? For pure storage products. Any questions so far? Cool. Right. So that is Fibre Channel network. This is the Fibre Channel protocol architecture, right? So let's talk about the Fibre Channel protocol. So layer 4 and layer 3 are actually, you don't have to go through much. Layer 4 is basically, okay, what kind of Fibre Channel protocol we are using? So are we using like IP based, Scuzzy based, or some kind of ATM link or something like that? That is just talking about it. Then layer 3 is basically a general equipment layer. So what kind of equipment you have, your HBA card and all this stuff. So layer 4 and layer 3 don't actually contribute that much. The ones you have to understand is FC2, FC1, and FC0. FC2 is the most important layer in Fibre Channel protocol. This is where they build the protocol structure. So this is where you'll know, like, okay, what is the data included? How do I send my task? Who am I sending the task to and all that? Which worldwide port name, worldwide node name should I send to? All that is basically done in Fibre FC2, right? Coding and decoding is done in FC1. So this is where you have your 8-bit over 10-bit, right? And also your CRC, so like your cyclic redundancy checks, so like CRE and so forth. So you want to do cyclic redundancy checks, error checking and all that. That is done in coding and encoding layer, right? So this is not only for just sending the commands, it's also for checking for errors. And physical conversion is your 1010, right? So these are the three main layers. Comparably, the layer 4 and layer 3, not so important. But you have to remember these three layers. They will always ask the question of which layer does the Fibre Channel structure its protocol? Or where is the protocol being structured in Fibre Channel? A, B, C, D, FC1, FC2, FC3, FC4, or FC0. And then you have to, sometimes they'll tell you, okay, they'll say FC1 equals, then you have to give A, B, C, D answer. Okay, FC1 equals physical conversion, something like that. So you just have to understand which layer does one. Generally, just keep an understanding on a high level. If you just understand on a high level, you're fine, right? FC3 and FC4, nothing much to talk about. FC3 is basically your equipment, what kind of equipment you're using, what kind of HBA card, maybe if it's a storage, what kind of interface module and all these things. FC4 is what general protocol you want to use. Either you want to use Scuzzy, you want to use IP protocols, and all these things. So it doesn't mean that Fibre Channel cannot run IP. It can, but it runs IP in a totally different way, right? You will not see the IP address and all that stuff. If you run Fibre Channel, generally you don't run, if you run IP on Fibre Channel, you're using like Fibre Channel over Ethernet and all these things. But Fibre Channel itself, yeah, you will mostly run Scuzzy. ATM used to be in the old days, but now they don't run ATM anymore. Okay, so generally you just see Scuzzy, right? Make sense? Any questions? I know most of you guys are probably falling asleep already. No worries, no worries.
How about the encoding process in
The encoding process is the same.
It's similar, like in
8-bit to 10-bit. Yeah. Yeah, similar. So just depends on how many encoding bits they use. If they use like a 8 to 10 or like 12 to 10 or something like that, depending on the encoding layer, it's always extra 2 bits. That's it. Make sense?
Yes, yes. For the encoding, sorry.
Yeah.
The key point is on start bit and end bit, right?
Yes. They'll always add 2 more extra bits.
Yeah.
That's all.
So can you give some example for the exam as for encoding? Yeah.
So let's say, like you said just now, the data, let's say your data is 10101111. This is actual data, right?
Yeah.
What they will do if you're using encoding of, say you're encoding on 8-bit to 10-bit, so 8-bit, for every 8 bits you have 10 bits of code, they will add 2 more bits. So your code will actually look something like this: 11010 1111 0, right? So this will be your start bit, and this will be your end bit. Okay? So they just add 2 more things.
Okay.
Yeah, that's all. Okay, generally that's how it works. If you're using 8 over 10, they'll all be higher, bigger sizes, but like 64 or something like that. So 62 over 64 plus minus, all these things. But generally it's just adding 1 or 2 more bits, right? The other thing you need to take care about is what they call, they will ask a question whereby, where is CRC done? Okay, CRC is what they call cyclic redundancy check. Oh, let's put here. So if you're a network guy, you'll probably see CRC errors everywhere here and there. Cyclic redundancy check is error checking. Okay, so that is done in this layer also, FCE1. Error checking, encoding and all that is done in FCE1. Okay, so anything to do with error checking, done in FCE1. And that's all. Any questions?
I'm sorry, Mr. President. Yeah, for the start bit is always 0 and end bit, or
that depends on the technology used. It won't be 0 and it won't be 1, but yeah, it will be one of those two bits. Yeah.
Okay.
No issues, sir.
Yeah, thank you.
Anytime. Right. So then we move on to FC topology. FC topology, there's only 3. Okay. You have point-to-point, arbitration loop, and switch network, right? Point-to-point is just basically, direct connection. You're connecting your server, connecting directly to your storage device that is in a point-to-point device, right? Arbitration loop is what they call using a hub, right? So basically you have a hub in between. So it's what they call a Fibre Channel arbitration loop hub. However, this is generally not used anymore because of how it works. Because we use a hub, right? Clear all these guys. Okay. So if you use a hub, so a hub in between, all the devices are connected to the hub. You can see it's already a problem here. Basically, you have a single point of failure. If the hub fails, the whole network is down. Not only that, the hub works, or the loop, arbitration loops work in like a token mechanism, right? So everybody will have the token. So one guy will get the token. He will use the token. So let's say I want to send traffic. So he will send traffic using the token to this guy. Then this guy will retrieve the token. They say, okay, I want to send traffic to this guy. And whoever has the token is the only one that can talk. So that's how the arbitration loop works, right? And it works in a loop in a clockwise manner in some sense. So this guy will get it first, then this guy will get it, this guy will get it. So everybody has to take his turn to talk. And it can connect up to 127 devices, and it's not recommended at all. Nobody will, in their right mind, recommend arbitration loop to anybody, right? There are situations where you might have to use it, but rarely anybody would recommend arbitration loop, even though it's a cheaper version than the switch network. If it might be 10 or 20,000 cheaper, but people will still prefer the switch network. Engineers at least. Of course, trying to convince the management why you need it to spend another 20,000 for switch network, that will take a long time, but generally the sentiment will get through, and you tell them how it works. You spend a lot of time telling like there's a lot of problems, single point of failure, all these things. Yeah. So people don't use this. What you have to remember is the number of devices, right? I have seen 2 or 3 questions come out at least. Okay, for arbitration loop, what is the maximum number of devices that can be connected? 127. For switch network, it's up to 16 million devices. Okay, switch network is the topology we generally use for Fibre Channel, right? So basically, it's server, switch, storage. This is what you call a switch network. So this switch can be used for like many other things. You can have another Fibre Channel switch, server switch, storage, right? And then you can do something they call zoning. You can do zone 1, zone 2, and so forth. Later we'll talk about zoning, don't worry. Most likely, after lunch, don't worry. But just, I think we'll stop at the topology first. Later after lunch, we'll go and continue back because, we have a lot of things we need to talk about. So I know you guys are having like your fasting month and all this stuff. So if you're not having lunch, don't worry. Just take a rest. Yeah, have a power nap if you need to, and just freshen yourselves up. And we will be back after lunch. Don't worry. So we'll stop here at fiber channel topology before we continue on. Because once we start continuing on, it's best not to stop, because these are like going to ports and all these things. A lot of things to talk about. So we'll stop at topology first. Is that all right with you guys?
Yes.
Okay. I know it's already a lot of information here and there. It's a very theoretical stuff, right? I understand. Okay, so we'll take a break from 12 till 1. So let's give it at 1:10. So I'm supposed to give you another, 10 minutes extra break. So I've used up my 30 minutes morning session break. So we'll be back at 1:10. Is it okay with you guys?
Okay. Yep. Thank you so much, sir.
No worries, sir. Thank you. So we'll be back at 1:10. Thank you.
Emangnya kagak apa? Hmm. Di Bapak itu. Islam apa? Hah? Gua ada bus ini. Wah. Entah. Pasti apa. Apa dia ada. Jangan dibuka. Biar saya buka.
Abang, kakak, mau dimarahin, mau dicubit satu-satu sini. Hah? Mau dimarahin, mau dicubit.
Ini bejannya.
Kamu udah minum obat belum? Hah? Kakak?
Belum, Pak.
Udah minum obat belum?
Belum, puasa. Obat satu aja.
Obat batuk belum?
Tiga-tiganya.
Satu aja.
Yang mana?
Obat batuk belum? Obat batuk aja di sini. Batuknya kakak enggak kan? Gak apa kasih masuk karena obat batuk. Yang banyak.
Betul. Obat. Abang minum obat nggak?
Hah? Abang batuknya gede nggak? Gede banget nggak batuknya? Hah? Gede banget?
Gede.
Gede.
Nanti ibu itu.
Udah nggak boleh lagi, udah. Masak lagi. Kali aja tapi udah. Boleh habisin boleh.
Enak ya.
Ya.
Kayak nggak puasa ya.
Nggak boleh berisik ya.
Papa, what's up? And what chapter down there?
All right, guys, we are back. Hold on there. So I hope everybody is doing fine. Everybody had their rest, and we can continue on. Is that all right with you guys?
Yes, Raven.
Yeah. Sounds good, sir. Sounds good. Right. So we were at Okay, Fibre Channel. Right. So we'll continue on with the topology. Of course, we currently know that switch network is the best topology for Fibre Channel, and it's the most widely used topology in Fibre Channel that sense. Now we come to the confusing part. Okay, so how you use Fibre Channel? Basically, on a Fibre Channel switch, every port in the Fibre Channel switch, there are certain types of different requirements, certain types of different, let's say, attributes which you can set. So you can set a port as an F port, or what we call a fabric port. Sorry. Basically, a fabric port is allowing you to connect to the Fibre Channel fabric. Then if you have a server or something like that, that will be on a node port, right? You have also a fabric loop port. If you want to connect some kind of Fibre Channel hub, right? And if you're connecting like a server in a node loop port, it will be a node loop port. And yeah, basically any other devices will be just loop ports, right? There are other ports like the general port. You have, actually, if you go inside Wikipedia itself, don't take my word for it. Take Wikipedia, so just go to Wikipedia, or just can say Fibre Channel port types. Okay, so you go into Fibre Channel port types. So this is from Juniper. You can see node port, fabric port, and all this stuff, right? There will be other ports also. There's the most mainly used one are, of course, node ports and fabric ports, but you can go here. Yeah. You can see the different types of ports. So the main ports will be node port, fabric port, and the other port will be expansion port. So expansion port will be connecting two different Fibre Channel switches, right? Then you have FX port, EN port. There's so many different types of ports. So if you want to really use Fibre Channel, you have to understand the different types of ports. So you must know, like, if you want to connect to a server to a switch, you must designate the port that you connect the server to a switch to a fabric port, right? And as long as you have a Fibre Channel HBA, host bus adapter card, as long as you have a Fibre Channel HBA, that port will be a node port, right? So to connect that node port to the switch, you must then ensure that the switch is having a fabric port or what they call a universal port. There are certain other ports that you can use. But let's just take, for this instance, you have a node port and you decide to put this as an expansion port, so E, the node will not connect. So that's another thing. So you must establish the port names there. Not only you have the WWNN, WWPN, you also have the nodes and the ports, right? So make sure the ports are correct. Once the ports are set up, generally, if you set up a fiber channel network, you will rarely go back. If you set up the fiber channel network properly, you will rarely go back and reconfigure the network. I have seen fiber channel networks that were up and running for at least 10 to 15 years with no issues, right? Of course, maybe the port speed might be outdated and all this stuff, but generally they will see no issues because fiber channel is such a protocol whereby until the switch fails, which is rarely, that is also another rare scenario, because fiber channel switches are somewhat quite hardy switches, very, very, they call it, they can take the beating for some sense. So they will rarely go above CPU level and all these things, and they will just generally just stay there for 10, 15 years. So once you set up the network properly, the only headache will be when you set up the network, right? After you set it up, when it starts running, it's totally fine. You won't see further issues with it. So you need to take note of the certain ports. So you need to know, like, okay, if the question asks you, I have a fabric port, what are the types of ports that can connect to my fabric port, node port, a general port, universal port, and all these things. If I have an expansion port, what is the expansion port used for? Is to connect switches. So you want to connect one fiber channel switch to another fiber channel switch, you will establish an expansion port here. So E port, and then you connect it to another expansion port of another switch. Right? So that's how it works. So you must establish the port connections first. If you want to establish connections to any loop device, basically it's just a L at the back. Anything like a fabric port will be fabric loop port, node port will be node loop port, and any other devices will just use a loop port. You also have a R loop port and all this for routers and all that stuff, but yeah. So there are certain types of ports. I think down there they do tell you some ports. Yeah. Probably in your notes, you'll see there are kind of a few ports like a G port, FL port, and so forth, right? So here they're just showing some ports, not all the ports in that sense. Make sense? Any questions? Cool. No worries.
No problem. Yeah.
So I think maybe some of you guys are already familiar with Fibre Channel. Have you played around with Fibre Channel switches, sir?
Yes, I have this experience before.
So you have experience with Fibre Channel switches. So you have set up a Fibre Channel network, sir?
Yeah, actually, how to say, like 1 month ago?
Okay,
not 1 month, sorry. 6 months ago, I bought the new server in my lab, and then I'm using this one right now.
Fibre Channel.
Yeah.
That's cool. So you're using a switch network or a point-to-point or?
A point-to-point, actually.
Point-to-point. Should try to play around with the switch, sir. Just buy a simple switch and just, I think you can get some really cheap switches now. They're quite cool stuff.
Yeah.
No worries. All right. To run Fibre Channel, you must run a Fibre Channel HBA, or what they call a host bus adapter card. This host bus adapter card will be set on the server. So you'll plug this onto a server motherboard. They will have a pin there. You plug it all in, and then you can run the Fibre Channel. You must run Fibre Channel host bus adapters. The other host bus adapters, of course, like your NIC cards, your Is Crc host bus adapter, and all this stuff. But for Fibre Channel, you must run Fibre Channel host bus adapters. Once you plug it in, then you will have to also buy the Fibre Channel, like SFPs. So you have to buy the SFPs. Genuinely, I think nowadays, the host bus adapter card is cheaper than certain SFPs. Some SFP prices can actually be very expensive. This guy's, ooh, man. Like if you go online and see, like 32 gig fiber SFP price. You can see the price. Now this is for the whole card itself. Let's see if we got the price for one of these guys. Yeah. So you can see the SFPs are not cheap. This is a small SFP, is 1 gigabyte fiber. This is for 16 gigabyte. We have 32 gigabytes, about 1006. This is a cheap guy, I guess. So it's only about 10 kilometers, all right. Yeah. So SFPs are genuinely expensive. The good ones. You can get cheaper ones, but yeah, we generally don't try to get the cheaper ones. We try to get the good ones, right? So they are not cheap. Like these guys and all this stuff, I don't really trust these guys, right? 81 bucks for 10 gigabyte SFP, very, very debatable. Something like this would look all right, but 81 bucks, no, right? Maybe it's really cheap stuff, nobody knows. Maybe a Cisco knockoff or something like that. So you'll have to buy those SFPs, you'll plug those SFPs in. After they are plugged in and used, then you can connect your fiber and all this stuff. But you have to buy the host bus adapter card, and then you have to buy the SFPs, and then the cables, of course. Okay? And that will be Fibre Channel. So they don't talk much about zoning and all this stuff, but if you want to know about zoning, I can teach you. Zoning is a protocol that I think later on they will cover, not in this chapter. But zoning is a technology used in Fibre Channel to differentiate connections, right? So no issues there. So here they're going to go and compare between Fibre Channel and Fibre Channel over Ethernet. Fibre Channel over Ethernet is straightforward. It's basically using Fibre Channel protocol, but establishing connection over Ethernet, right? So Fibre Channel over Ethernet protocol is used to transmit Fibre Channel signals over lossless enhanced Ethernet infrastructure. Fibre Channel over Ethernet encapsulate FC data frames in Ethernet frames and allow the service traffic on a LAN and SAN to be transmitted over the same Ethernet. So how it works, if you take the Fibre Channel protocol, so you have FC0, FC1, FC2, and FC3, 4, and so forth. The only thing that changed is basically FC2, right? So basically from mapping Fibre Channel, they map it to Ethernet, and that's it. Once they map it to Ethernet, so you're running Ethernet frames, hence you're running MAC address and your physical IP and all this stuff, or your physical, what do you call this, Ethernet frame, right? So Ethernet frame uses MAC address. MAC address basically is your machine address. So yeah, that's how they run it over Ethernet. Nothing much, not much different. So you just have to remember the change in the protocol stack. The only changes are basically from FC2 and below, right? So FC2, they just encapsulate the Ethernet frame and then they convert it into a MAC address and send it over the physical link. Whereas here, they will encapsulate it into a Fibre Channel packet, send it over to the encoding, decoding, and send it over the physical frame. That's a big difference here and there only, not much. So FCOE retains the protocol stack above FC2 and replaces FC0 and FC1 with the Ethernet protocol. FCOE can be seen, I think, you can try like Cloud Shark FCOE. See if you find anything. Fibre Channel over Ethernet. So yeah, there is a Cloud Shark frame for this. So you'll see something like this. Fibre Channel over Ethernet. Basically, you're sending an Ethernet frame, right? So Ethernet here, source destination. This is the MAC address, right? FCOE is just version of the what Fibre Channel protocols are you using, and then they can send it through the Ethernet frame using the MAC address, source and destination stuff. And this is how the frame is sent, okay? So anything converted to Ethernet or IP can be packet captured. But if you just use pure FC protocol, you cannot capture the packet, right? You have to use different tools for that. Make sense? Any questions? Cool. So that's Fibre Channel over Ethernet and Fibre Channel in regard. So now we'll move on to SAS and SATA. These are more of connections or interface connections for like disks and all this stuff. There are also cable connections, but yeah. So background of SAS. So parallel bus, basically parallel architecture reached its peak. And then you also have issues whereby like Fibre Channel, InfiniBand, and Ethernet have some advantages and disadvantages. Like Fibre Channel and InfiniBand being too expensive, and being if you want to do a networking on Fibre Channel or InfiniBand, requires certain complex networking technologies, right? Is Crc, on the other hand, has high latency because of the so many encapsulation and decapsulations and all that, and the transmission rate is fairly low. So trying to find something in between is where they developed SAS, serial attached Scuzzy, using the Scuzzy command but in a serial transmission rate, right? So what is serial attached Scuzzy? So serial attached Scuzzy is a standard use whereby you use serial cables but still maintain the Scuzzy bus architecture, right? So serial attached Scuzzy uses serial technology to achieve higher transmission rate, better scalability, and compatible with also previous SATA disks. So serial attached Scuzzy appoints the point-to-point architecture. So you can see if you compare SATA and Scuzzy, I mean serial attached Scuzzy, SATA will be 1.5, 3, and 6, right? So it'll be 1.5 gigs, 3 gigs, and 6 gigs transmission, right? Serial attached Scuzzy, however, is just double the transmission of SATA. This is the max rate of SATA, and this is the max rate of serial attached Scuzzy. Okay? If you want to do a comparison, go ahead. I think later on they do show you the comparison, maybe. No. Right. Anyways, so that is the main component of serial attached Scuzzy. It's basically double the performance of SATA, right? And it also supports the full duplex mode like SATA. No issues there. So SAS protocol layers, basically still using the Scuzzy protocol. So you have the application layer, which is either Scuzzy, or you can backtrack to ATA if you're using SATA or whatever. Transmission layer, you have your Scuzzy transmission, your SATA transmission, or some kind of management protocols. And then you have the port layer. You don't have to remember this guy, right? They generally will not ask protocol layers in the exam. It is good to know, right? When you are actually in the storage environment, it is good to know, but generally in the exams, they do not ask you regarding protocol layers and stuff, because if you want to remember each and every protocol layer, there are a lot of things to remember. However, if we look at the protocol layers, just to give you some input, physical layer as usual is the 101010. Okay, the Phi layer is where you do your encoding and decoding. So here is where you have your 8010. Okay, you'll have where you have your 8 over 10 bits and all this stuff. The link layer basically tells you what kind of SAS protocol you are pushing through. So you're either using Scuzzy SAS protocol, SATA SAS protocol, doesn't matter. The connection is SAS. The protocol that runs in between can be ATA Scuzzy protocols or Scuzzy protocols in that sense also. Port layer just, yeah, basically it's a transmission between your transmission layer and your link layer. Nothing much here. This guy doesn't do much, but it's a layer there. The main layers are these three guys. Okay, so you have to remember, link layer is basically where the what do you call this? The SAS protocol builds its architecture, right? Physical layer is where you do your encoding, decoding, and physical layer is where you send your data. Okay. Then what you have to remember for your exams is these highlights. So SAS has a technology called expanders. Theoretically, SAS you can expand up to about, not mistaken, about 65,000 disks, 65,000 something like that. You can expand up to 128 expanders. So you can see the expanders here. Generally, when you connect a SAS connection, it's what you call a wide link connection. So it's 4 times 12 gigabytes. So each one 12 gigabytes. And if you do expander, they will basically cut it in half. So then if you do one expansion, it will be 6. Then you do an expansion again, it will be 3. Then it will just keep getting lower and lower and lower. Huawei, as a storage vendor, only supports 1 plus, if not mistaken, it's 25. So I think it's about 1 plus 5, right? What I mean by 1 plus 5 here is 1 storage controller plus 5 disk arrays, right? So generally, each disk array, if you're using a 2.5-inch disk, can have 25 disks each. So each disk array you can have, you can go up to, if you use the 25 disks, you can go up to about 125. However, the maximum you can achieve is 175 disks. This is the sweet spot, right? So to achieve this, Huawei has few different types of disk arrays that you can use. If you are using a 2.5-inch disk array, you can have 5 of those. You can achieve 125 disks. Of course, yeah, with the full capabilities of 12 gigabytes SAS. So they're trying to maintain this 12 gigabytes. They don't want to go less than 12 gigabytes. There are other storage systems that let you go below 12 gigabytes and stuff, but Huawei, best practice, they try to keep the connection at 12 gigabytes in that sense. Okay. Why? So that they have the best performance, right? So 1 plus 5 technology, basically, because you can buy integrated storage controller. So the integrated storage controller will have 25 disks by default. So 25 plus 5 times 25, right? You have another 25 here. 5 times, basically, yeah, 25. So you'll get 125 disks here, plus the other 25, you'll achieve up to 150 disks. There is another method how to reach this, which is using something called the high density disk enclosure. This is for the 3.5-inch disks. So if you want pure capacity, like using NLSAS, Huawei has something called a high density or HD disk enclosure, which can obtain up to 75 disks per enclosure. 75 3.5-inch disks. Heavy, very heavy, of course, but very, very powerful. So using this guy, you can have 1 plus 2 HD disk enclosures, right? So the one you can have like a 2.5-inch, or even if you want to use a 3.5-inch, you'll have 12. So the one guy will be 12 plus 150.
Sorry, Prem.
Yep.
Could you explain once more about SD?
HD. Okay, so yeah. HD actually best way to explain is show you the pictures. So hold on. Here is that guy. Close this guy. Okay. Oh, I closed it. And go back to our 3D tools. Okay. Ah, man. Why is every time this page always lagging? Anyways, maybe I can show you a picture here.
It's okay.
Yeah, no worries, no worries.
Internet problem or maybe?
I don't know. I always have this picture problem with only Huawei websites. Okay. So this is a high density disk enclosure. So basically, yeah. So it's one disk enclosure, but you can have 75 disks, right?
Okay.
So basically you can have up to 75 disks in one disk enclosure. Each disk here is a 3.5-inch disk.
3.5, okay.
3.5-inch disk. So very heavy stuff, believe me, very, very heavy. If you fill it up.
2.5, right?
Not 2.5.
Yeah.
3.5. So you can buy 2 of these. So basically, because each guy has 75 disks, so if you buy 2 of these, you reach 150. The sweet spot for disk is about 165 and 175 plus minus. That's the sweet spot. You don't want to go more than that. You don't want to try to get less than that, right? You're trying to reach that the sweet spot there. Make sense?
Yep. Yes, sir.
So to achieve that, Huawei has released this product, the high density disk enclosure, which for some reason won't open here, so that you can achieve that 1+2 controller, right? So basically one controller enclosure, one integrated controller enclosure, and 2 disk enclosures, still achieving the 12 gigabyte SAS rate, right? Else you will, because you use multiple expanders, this rate will go lower and lower. So if you're using the, just put it in text here. So if you're using a 2.5-inch disk, Huawei recommends, if you're using the integrated controller, so 1+5, which will lead up to about 150 disks, right? If you're planning to use 3.5-inch disks, Huawei recommends the 1+2.
1+2, okay.
So it will reach up to about, if all are 3.5-inch disks, will reach up to 167 disks. 162, sorry, disks. Because if you're using all 3.5-inch, right? So if you use the integrated controller, it's 12 disks plus 75, so 150, so 162. This is the maximum you can reach with Huawei, right? Recommended. If you want to go further than that, they will say the speed will get lower and all that, which is true because of how the expander works. So if you're using SAS, this is a very, very powerful thing because they can do this expansion. You can remain at 12 gigabytes or you can keep expanding and then get to slower speed in the end. Some storage vendors do go and cap their speed up to about 3 gigs. So you can do double the expansion, which is all right, but I would say this is not the way to go, right? There are other methods to do it, but yeah. Okay. So provide serial communication mode to allow multiple data channels to communicate with devices at full speed, binds multiple narrow ports to form a wide port. Usually one wide port will have 4 narrow links. Uses expanders to expand interface, providing excellent scalability and works in full duplex. So yeah. So scalability of SAS. This is one of the main features. So using SAS expanders, you can support up to a maximum of 16,384 devices. You can go up to 128 expanders. So basically 128 times 128, you'll get that number. But generally nobody will go all the way up to 128, right? We will leave it at a maximum 2 expanders, maybe about 5 expanders and all this stuff. We will never go to, nobody has reached this 16,000. If you want to reach this 16,000, those disks at the end will be extremely slow, right? Extremely slow transmission rate. So it can expand to 16,000, but we will not do the expansion to 16,000 because it's a waste of resources in some sense. However, these are the capabilities. So if you do that in the calculator, 128 times 128, you'll get this number. That is how many disks or how many times you can expand in some sense, right? So the sweet spot is 100 and yeah. So you see the sweet spot is 168. So to achieve the 168, using a 2.5-inch disk, you have to have the 1+5. If you're using the 1+2 method, high density. Any questions? Okay. So generally a SAS cable has 4 channels, so each which supports 12 gigabyte. So what will happen when you buy a normal SAS, when you use like a controller, you'll see 2 expansion ports there, right? Expansion port 1 and expansion port 2. You connect a SAS cable. This cable is basically what you call a wide link cable. Connect to this expansion module. From that expansion module, you use internally, they'll have SAS expanders and all that, which will expand everything to 12 gigabyte connections, which is very, very powerful. So all your connections are about 12 gigabyte. SAS, because it derives also from Scuzzy, serial attached Scuzzy it's called, are connected in the form of a loop, also called a chain, following the Scuzzy method, daisy chain method, right? A cable supports up to 4 times 12 gigabytes bandwidth, which limits the number of disks in the loop. So a maximum of 168 disks are supported in a loop. That is, a loop consists of a maximum of 7 disk enclosures with 24 disk slots each. Because Huawei has a 25 2.5 inch, so that's why it's a 1+5. If it's a 24 disk, yeah, you can go a bit more than that. Or the 1+2. Okay. If you're using a separation disk enclosure, then yeah, why not? Go with a 1+6 or 1+ something like that. Possible. But if you're not using a separation disk enclosure, then yeah, that is the theory from Huawei. So it's always 1+5 or 1+2 if you're using high density. Right? That's the way it is. If you're using high density, you're using all 3.5 inch, then yeah. If you're trying to exceed the number of 168, there will be a problem, right? So that is the principle of SAS. Any questions? Then we talk about SATA. So SATA is actually serial ATA. Okay, this was a technology we used in our old CD-ROMs and all this stuff, right? This is the cable that we connected, the back SATA cables at the back there and all this stuff. We generally now tend to stay away from, there are still certain SATA connections on your motherboard and here and there, but you will rarely see SATA anymore. You'll see mostly serial connections nowadays, right? Serial SAS connections and all this stuff, or PCIe and all this stuff. SATA, not so much. So instead of a simple PATA improvement, the bus structure is brand new. So the SATA structure is upgraded on the bus. A SATA bus uses embedded clock signals and has better error correction capabilities. SATA has better anti-interference capabilities compared to parallel ATA. SATA is designed for entry-level applications, not as powerful as Scuzzy in terms of big data throughput or multi-thread transmissions. So yeah, if you're comparing SATA and SAS, SAS is generally 2 times just 1 time more powerful than SATA. Whatever SATA has, SAS has, but it's generally just 1 times more powerful in performance. So if SATA is 10 gigabytes, SAS will be 20 gigabytes in that sense. Okay, but the maximum for SATA in terms of throughput speed is 6 gigabytes. So SAS is 12. Okay. So that is SAS and SATA. Any questions before we go into PCIe and NVMe? Cool. No worries. So PCIe, short for Peripheral Component Interconnect. PCIe means Peripheral Component Interconnect Express, right? This is actually the same technology that you use to plug in your motherboard and all these graphic cards and all this stuff, right? So when you're plugging in your graphic card, basically generally you're using PCIe slots. So it's not a new technology, right? It's not something that just came out or something. It has been there for a while. Sorry. Okay. This is what they call PCIe is an interface connect or interface standard for connecting high-speed components. In general, you definitely have seen it before, at least on your PC motherboard, for your GPUs and all this stuff. RAID cards also use PCIe, so it has been there for a while. It's not something new, right? So what is PCIe or why PCIe? PCIe is used to obtain significantly improved system throughput. So it's generally much more faster, scalability and flexibility at lower production cost. It is not to say the cheapest, but it's also counted pretty cheap. Okay. PCIe, however, comes with different physical configurations. So when you buy a PCIe like a slot for Huawei and all that, they will ask you how many lanes of PCIe you want. So you have to understand how PCIe works. So there are multiple lanes. You will find like there will be something called ×1, then you will be something called ×4, then you'll have all the way up to like ×32, right? So just put a dot there, right? 1, 4, 8, 16, 32, and so forth. I think now even they have 64 and stuff. So depending on the lanes, okay? What do they mean by lanes? Actually, you probably have seen it, right? You just don't understand the lane concept, right? PCIe lanes. Maybe you can see there's an image. Okay. Something like this. Okay. So you say if you have a ×1, basically it's 1 lane, 4 lanes, 8 lanes, 16 lanes, 32 lanes, and so forth. So you can see the card just keeps getting bigger and bigger. So this is how you determine your connection. So they say, okay, we are connecting by PCIe ×16, right? So you know it's a 16 lane card. It's quite big in all this sense. Okay. So you need to know that kind of things. So basically, the more lanes you have, the more basically the more faster it can be. No problem there. So PCIe is generally very, very fast. And Huawei uses this to interconnect between their controllers. So if you have like a separation controller module, so you usually have like one controller box with 4 controllers inside. If you want to connect these 4 controllers to another set of 4 controllers, and then you want to interconnect them to another set of 4 controllers here, and then you interconnect them this way. Generally, they use PCIe for the connection, right? So if you want to know the speeds of PCIe and all that stuff, I think currently we are running, the current version of PCIe is, I think you have PCIe 6.0. PCIe 6.0, yeah. 6.0, I think, can go up to about 256 gigabytes per second, not mistaken. Yeah, it's about 256 GB. Huawei is using the 128 GB and also, I think, PCIe 5 and PCIe 4 in that regard. So Huawei is using a version lower than this. Of course, they will update this later on. When the new version of Ocean Store comes out, generally, probably they'll use PCIe 6.0 and stuff. Okay. So PCIe, actually, PCIe and InfiniBand have a story together. When we reach InfiniBand, I'll tell you that story. PCIe and InfiniBand, that is a more of a sad story for InfiniBand, but yeah. So what is the main purpose of PCIe? High performance, high bandwidth serial interconnection. That is what PCIe does. It is not a new technology. It has been there for quite some time now. And even PCIe, like PCIe 4.0 or 5.0, I think PCIe 5.0 just came out in 2019. That's when Ocean Store Dorado V6 was, I think, scheduled to come out somewhere around there, somewhere around May 2019, right? PCIe 6 is still fairly new. Not a lot of people still use it yet, but PCIe 5 people have tend to use it already. I think Huawei uses PCIe 4, yeah, 64 gigabytes per second, not mistaken, plus minus, right? And double check that. Oh, I think it's 128 gigabytes, not mistaken. Anyways, so the PCIe protocol structure is very simple. You have your physical layer, your data link layer, your transaction layer, and your application layer. So much more simple than any other protocol, right? That's why it's very fast. The less protocol overhead, the less things you need to do, the faster your protocol is. So PCIe devices uses or layers include physical, data link, transaction, and application. So physical is basically how you send your transactions to. Data link layer is where you do your error checking and stuff. Transactions layer is where most of your protocols are built. And your application layer is what kind of application you're using. Nothing much. Fairly straightforward protocol. So you just have to remember these 4 layers. You're good for the exam, right? They won't ask you which layer does what. Because PCIe protocol, there's a lot of things you can actually learn through PCIe. Yep. Any questions? Cool. All right, then we talk about our good friend NVMe. So NVMe is basically non-volatile memory express, right? Yeah, yes, sir. Go ahead, sir.
Yeah. HCIA is still under continuous development.
Sorry, sir. Can you speak a bit louder, sir? Sorry.
I read internet. PCIe is still under continuous development.
Yep.
The most common version now are PCIe 1.0. PCIe SIG has announced the release of PCIe
Sigma
2.0 January 27, and PCIe and PCIe 3.0 August 27, and current development in 2021 toward exit.
Okay. So the question was, sir?
So and current development in 2021 to what extent?
So you, sorry, sir, don't understand that one.
Okay.
Maybe you can phrase it in a different way. So you're telling me, so what is the current development of PCIe or
2021?
So 2021, I'm not too sure, sir.
Okay.
So,
Yeah. Okay.
The last I know is no worries. So, but the last I know, PCIe 6 came out in 2019 June, I think, somewhere.
Okay.
Yeah.
Okay.
That was PCIe 6.
Thank you, sir. I'm sorry.
No worries.
Right.
Good question, sir. Don't worry. Any question is a good question, sir. But yeah, in terms of PCIe, what's going to happen in the future and all that stuff, not too sure, but I know they are currently still at PCIe 6. I think that is the current technology.
Okay.
They call it PCIe SIG, right? PCIe SIG, right? Or the PCIe SIG, basically the worldwide group, peripheral interconnect, peripheral component interconnect express group. They are the ones who will said they will release something in, I think they should be releasing something soon this year, I think. Not mistaken, right? And then yeah, they say it's going to be double of PCIe 5. So PCIe 5 is 128 gigabytes. PCIe 6 should be 256. So we do not know. That is the future. So yeah, maybe this year we'll hear something from them. And Huawei will have to probably change their the topics here and there, right? Right. So now we talk about NVMe. So what is NVMe? Okay. So NVMe, yes, sir, go ahead. Cool. So what is NVMe? So NVMe basically is non-volatile memory express. NVMe is a standard that is set on PCIe SSDs, right? A direct connection of native PCIe channel to the CPU can avoid the latency caused by communications and all this stuff in between. So NVMe, where would you find NVMe? Generally, you'll find NVMe technologies only on storages or servers, right? Okay. So NVMe, non-volatile memory express, is basically it's not a very old protocol. So it's a new protocol developed for wouldn't not say so new, also not so old, not so new. Generally in the middle stages there, right? It's generally a protocol for high-speed storage media access, right? This is trying to overcome like the developments of Scuzzy and all this stuff. But generally, it's still a bit expensive in the market, but maybe in the future start getting lower and lower, right? So NVMe is seeing a lot of track in businesses. So businesses are having a very good reviews on NVMe. They're saying it's very fast, very good for fast data, for like big data analytics and all this stuff, right? So NVMe, where did it start? So basically, the storage community have been asking, or basically the storage environment, people that work in storages have been asking for new updates on certain like old school protocols, physical interfaces like SATA, SAS, and all that. So some of the connections are fairly expensive. Like SAS is generally 2 times more than the price of SATA connections, right? So they were trying to find something that is very fast, even if the price is expensive, but it should replace the connection sequence because you have to keep up to date with the current connection speed. Nowadays, you already have like 100 gigabyte Ethernet and all these things. So the storage community was lagging behind. That's where they developed like PCIe. They tried to use PCIe connections, which was pretty good. They came up with PCIe and all that stuff, the connections, interconnections. But that is for connecting like storages and servers, right? But what about the disk interfaces, right? So disk interfaces, we still have only SAS and SATA, right? So this is where the emergence of NVMe came about. So now you'll see NVMe disks, NVMe SSDs and all these things. Those are flash disks, right? So they are trying to replace the SAS connector with NVMe, okay? Connections between, like if you want to do a connection between like what we showed you just now, controller to controller. So controller to controller, that will use PCIe, right? Okay, my PCIe doesn't look that good. But if you have, where you will see NVMe in Huawei storage is if you have a disk array, the disks will be NVMe disks. Okay. Compared to PCIe. PCIe is the controller connections. NVMe will be used for the disk connections, right? Because of the, they have the RDMA background and all these things. So NVMe protocol stack. So compare your standard SAS protocol stack compared to your NVMe, you can see so much more difference, right? So your SAS protocol stack, even though it's comparable, like you compare this to like other protocols like IP and all that stuff, SAS is already a very short protocol. You only have a few things to do, but still people tend to think that, okay, yeah, SAS still has a lot of stuff. Like transfer command, ready transfer, transfer data, response feedback. That's how it works. NVMe is just write command and finish, right? So it's a very, very fast, protocol in that sense. Generally much more faster than all the previous protocols. That's why NVMe disks are still very expensive. And yeah, since it's still a new technology, maybe about 5 to 10 years, then yeah, price will come down. So you compare the two protocol stacks, you can see the difference here. So if you are using normal SAS connections, you have to do the transfer command first. So transfer command, once the transfer command, then you ready to transfer, you say, okay, I'm ready to transfer. Then you start transferring the data. Once the data is done, then you'll get a feedback and then you're done. NVMe, however, you'll say, okay, I want straight away write. Once you're done writing, okay, I'm done writing. That's it. So it's a much more easier, faster protocol stack in the sense. Less interactions, so much more faster data transfer rates, right? So you can compare this. This is how the SAS and NVMe talks to the controller. So SAS, you'll have 4 times. You'll transfer the command. You're ready for the transfer. You'll then start transferring the data. Then you get a response. Okay, the data has been transferred. NVMe, you write, you're done, right? So once the write command is done, the SSD will just tell, okay, I've written everything. You have written everything. You can go do everything else. Much more faster. Okay. Any questions? Cool. So advantages of NVMe. So NVMe, we see a lot of advantages in terms of connecting via disks, right? The OceanStar Dorado using NVMe disk, you see so much more performance increase compared to using like SAS connectors and all these things, right? And you can use about like 100 gigabytes NVMe over Fabric, no problems. Very easy to achieve. Compared to like FC, so IOPS, NVMe is about the same as a Fibre Channel. In terms of latency, NVMe is actually has less latency than Fibre Channel. And Fibre Channel is already very fast. Total cost of ownership, yeah, NVMe, it uses everything that it has. Rather than Fibre Channel where you have to buy a huge network, a lot of devices and all these things, and you don't really use everything else, right? So NVMe is generally much more cheap in compared to Fibre Channel, right? Generally still much more cheaper in some regards and much more efficient, right? Cheaper maybe, I would say much more efficient, right? You use up what you buy, what you use. You generally don't tend to waste what you've bought, right? You make full use out of NVMe. Right. So do you guys want to take a break or are you guys okay to continue? It's up to you guys. You okay to continue? All right. So the next topic we'll go into is RDMA and InfiniBand, or RDMA, Remote Direct Memory Access. So what is Remote Direct Memory Access? Basically, it's a technology or a kind of technology created to bypass certain layers of the OS, right? So Remote Direct Memory Access is a method of transferring data in a buffer between application software on two servers over a network. So how it happens is like, okay, usually if you transfer the data in a traditional mode, you'll have to go through certain buffers like TCP/IP buffer, the drivers, the OS, and all these things. If you use RDMA, basically the application directly talks to the adapter. This is what you call Remote Direct Memory Access. It works both ways, right? So if the data is coming in from the RDMA adapter, straight away going to the application, it doesn't have to pass through the application the OS layer stuff. So it directly bypasses certain layers, making connections much more faster. But this technology, once again, can only be found on storage or server environments. It was created for storage to storage. Now it's being used in storage and server also. Same thing, storage and servers, storage and storage, yeah, same stuff. To bypass certain things, to directly let the application talk with the disk in some sense, right? Make sense? So you can see the traditional mode. So traditional mode, the application will have to go through all the different types of buffers to reach the adapter, right? With RDMA, the application buffer will talk directly with the adapter buffer. It doesn't have to go through the TCP/IP, the drivers, and all these things. So bypassing a lot of layers, making the connection or making the data sequence much more faster in performance. Okay. RDMA works with certain types of different networks. So RDMA works with InfiniBand. RDMA works with, yes, sir? Any questions? No problem. Okay. So RDMA works with InfiniBand. RDMA works with ROCE. Does anybody know what ROCE means? Or it's totally new? Okay. Basically, it just means RDMA over converged Ethernet. That's what ROCE means. So basically, it's running on the Ethernet layer, right? So ROCE means RDMA over converged Ethernet, right? So this is what it means. ED Ethernet. That's what ROCE means. Okay. So you have, of course, ROCE version 1 and version 2. ROCE version 1 is using Ethernet link, but using InfiniBand as the transport protocol. ROCE version 2 is basically using much more of an IP protocol and still using the InfiniBand protocol stack. But the network layer and all that, you're still using IPs, Ethernet switches now. You're not using InfiniBand switches anymore, right? So here, the network layer, you are using InfiniBand hardware and all that stuff. Here, you're basically using TCP IP Ethernet hardware, but still using a transport protocol as InfiniBand. So you still have some InfiniBand connections here and there. InfiniBand total network, everything is done by InfiniBand. And currently the major vendor for InfiniBand, I think, is still Mellanox, right? So Mellanox is the main vendor for InfiniBand in that sense. And finally, you have IWAP, which is total Ethernet, what do you call this? Ethernet environment, right? So IWAP is basically using, Ethernet. So it's depending on your budget in some sense. You want to use InfiniBand total network to use RDMA, or you want to use ROCE, or you want to use like IWAP and all this stuff. Totally up to you. Okay. So the advantage is RDMA works with different types of networks. So if you want to use pure Ethernet network, yeah, possible. But probably if your protocol will be like Scuzzy and stuff, right? If you want to use like InfiniBand, you can do so, no problem. If you want to use half InfiniBand, half IP protocol, possible, depending on how much is your budget here and there. RDMA protocol can work with all these guys, no issues, right? So nothing much to talk about that. You don't have to remember the software stack and all this stuff. Generally, you just have to remember what RDMA does in general. Remote direct memory access. Bypass certain layers of the OS, right? So bypass the buffers of the driver buffers, bypass the what do you call this? Yeah, all the OS stuff buffers and stuff, right? Any questions? Sorry. Cool. Then we talk about InfiniBand. So InfiniBand, how to explain InfiniBand? Okay, let's say there's a road, right? Okay, so there's a big road in between, and yeah, just put some kind of stuff here called road, right? So InfiniBand, if you put into a protocol, InfiniBand is actually the road, right? So it's a very clean, smooth highway, very well tarred and all these things. So cars can go on top fast. The cars are the protocols. So it can be like Scuzzy protocol, can be like IP protocol, all those different cars. Of course, my cars don't look so good, but I'm just doing, So InfiniBand is basically a transportation protocol, right? How you transport other protocols. The InfiniBand can be used with IP network, can be used with Scuzzy, Fibre Channel, and all this other stuff, right? So that is InfiniBand. So if you want to understand what is InfiniBand, basically it's the road. What cars you drive on the road, what kind of protocols you want to use, that's up to you. But the road is InfiniBand. And InfiniBand behaves the same like Fibre Channel in some sense, whereby if you want to use InfiniBand, you have to buy a few things. You have to buy something called a host channel adapter. And then you have for the target, you have a target channel adapter. And then you have to buy an InfiniBand switch. You also have to buy like InfiniBand cables, InfiniBand SFPs, SFP, all InfiniBand, right? So InfiniBand is not used a lot, but Huawei is using InfiniBand in their environment. However, this is for very, very high-end environments. It is not cheap. InfiniBand by default in Huawei runs at 56 gigabyte speed, right? Very, very fast, very, very powerful protocol. But the switches can be a bit expensive. So if you want to run InfiniBand, you have to buy the full InfiniBand environment. So you go here, you go InfiniBand switch, right? So InfiniBand is not a cheap product. This is layer 2 gigabyte. Why are they showing me gigabyte Ethernet? InfiniBand Mellanox. So the switch InfiniBand, yeah. So this is a cheap version, so 500, not bad. Yeah, it looks something like this. So even Dell has InfiniBand switches now, but you'll find InfiniBand, once again, it's a protocol transport layer only for storage and server communications. Only for storage and server. You will not see InfiniBand used anywhere else. It is purely for server to storage or server to server communication, right? Then the story of InfiniBand. InfiniBand was it's actually not a new technology. It was there since the dawn of PCIe. InfiniBand and PCIe came out around the same time, but somehow or other, PCIe got more track because PCIe was more widely used, like in your motherboards and all these things. So InfiniBand had to take a back shelf. Then there was a company, it was actually joint developed by IBM, HP, Cisco. A lot of guys came together and developed this technology. After that, they kind of like not abandoned it, but they passed it on to another company called Mellanox. Mellanox is now the sole provider for InfiniBand-based technologies. And slowly but surely, InfiniBand is getting more and more traction because of how InfiniBand works in the server environment. Very, very, very fast, right? 56 gigabytes minimum. You can go above that 150, 160 gigabytes, no problem, using InfiniBand, right? So the highlights of InfiniBand, you can use any standard protocol base, IP, standard Scuzzy, Fibre Channel, all the other types of protocols, no problem. InfiniBand is just the highway. What protocols you want to use, you use. Very high bandwidth and very, very low latency. It is also a lossless network, very well defined with RDMA, uses remote direct memory access, and transmission and installation is, yeah, pretty easy to achieve in some sense. Okay. So InfiniBand architecture, as usual, you will have your CPU, your host interconnect and all that stuff. And then you'll see something called host channel adapter. This is where the InfiniBand starts, right? So all these is actually still under the host. So this is like the CPU server. And the host channel adapter is the initiator, right? So the initiator will send its initiation to targets. So it can be either like a Scuzzy target, a Fibre Channel target. If you want to send it to a router and go to gigabyte Ethernet, no problem. So you can use all the different types of protocols, Fibre Channel, Scuzzy, gigabyte Ethernet, no problem. But you will require a host channel adapter, an InfiniBand switch, and a target channel adapter, TCA. These are the three main requirements. Or if you want to do a point-to-point for some reason, you need to have the host channel adapter and the target channel adapter. It's like the host bus adapter card. You have to specifically buy the card to use InfiniBand. And InfiniBand can be routed, no issues. Can be routed across like WAN and all this stuff. But in a storage environment, yes. It cannot cross the LAN, right? Yes, it'll definitely be in a SAN environment. It will not go to a LAN environment. So any questions on InfiniBand? So it works, if you are familiar with Fibre Channel, InfiniBand is kind of similar. How you set it up? You still need to set up the switch, you need to set up the connections, you need to set up the zones and all the stuff. So very, a bit similar in terms of configuration towards Fibre Channel. But it can run any protocol. You want to run Scuzzy protocols, Scuzzy, Fibre Channel, Ethernet frames, no problem. InfiniBand does the job. So you can see here InfiniBand in storage. So you'll realize, okay, this is like the converged storage, so the Huawei Ocean Store environment, and this will be Huawei Ocean Store 100D. This is like the distributed storage architecture. So InfiniBand in a converged storage environment is only for the server to talk to the storage, right? Only the server to talk to the storage. Whereas in the backend for the storage to talk to the disk, you're still going to use SAS connectors and all this stuff, right? It's just server to storage connection. That's where you find InfiniBand. For distributed architecture and all this stuff, so you'll have your distributed cluster, so your cluster of servers. So these can all be Ocean Store 100D, right? So Ocean Store 100D here. So the Ocean Store 100D device basically is the distributed server architecture for Huawei. Using that, you can have front-end InfiniBand switches and back-end InfiniBand switches to interconnect them, creating your high-speed distributed storage network, right? So that's what they are trying to tell you here. Any questions? No? So then we talk about, so that's it. Okay. So maybe the last one, we'll take a short break, then I'll continue the last one, go to the next topic. So InfiniBand layers, this is similar to like the OSI layer, not the 7 OSI layer, what do you call it? There's the 5 layer stuff. But anyway, it starts off with the application layer, transmission layer, network layer, link layer, and physical layer. Application layer is basically what kind of application you're using, so that doesn't matter much. Transmission layer is where they send, receive, and reassemble data packet segments. Network layer is where they do the protocol addressing and routing. Link layer is to provide data packet design and point-to-point connection to local systems and all this stuff. And physical layer is where they determine the connection rate. So you have to remember these layers. If you remember them, you're good for the exam. Okay. Interfaces for InfiniBand. If you're connecting a server to a storage, the server must have a host channel adapter and a storage must have a target channel adapter. In between, you can either have switches to do an InfiniBand network or InfiniBand fabric, or you can do a point-to-point connection using certain InfiniBand connectors. You'll find different types of InfiniBand connectors depending on what kind of speed you're using. So these are just some connectors from 10 GB to 40 GB. So 10 GB, 20, and all this stuff, right? SFP Plus and all that's still viable for InfiniBand, but they have their own SFPs in some sense. You need to buy the products. It's not free. Okay? Right. So before this last one, I'll just continue the last one, and then we'll finish off this chapter before we take a short break. Okay. So the last chapter is CIFS, NFS, and NDMP. So what is CIFS? This is talking about file transfer protocols, right? So file transfer protocols, basically you're talking about the NAS products. CIFS is basically what they call Common Internet File System. It was created for Windows to share files. It is actually developed by IBM, and IBM developed a protocol called SMB. SMB is Server Message Protocol. It was developed by IBM, but IBM at the time did not use it much. So Windows or Microsoft came and took that that protocol and realized it as CIFS. They redefined it as CIFS around 1996. And then they just kept adding features over and over. Now I think the SMB version 4 or something like that. But yeah, CIFS generally runs on a client-server architecture. It is generally used for Windows file sharing, right? That's all. That is CIFS. Just a bit of history, no problem there. Then you have,
sorry to interrupt.
Yeah, go ahead, sir.
Can you, okay, in the slide, so we can say that SMP is the same as CIFS?
SMB is CIFS. So basically, IBM created SMB, Microsoft took SMB and then redefined this as CIFS. But if you do packet tracing, so if you do like Wireshark and all this stuff, right? The protocol behind there, you will still see SMB. So it's still running SMB.
Okay, CIFS means SMP. So we can say that CIFS means SMP. That's correct?
You can say that, yeah. So CIFS is redefined SMB. So the CIFS uses SMB as a protocol.
Okay.
Okay, then you have the other guy which is NFS, or Network File System. Network File System is basically a file sharing protocol developed for Unix and Linux environments. Okay, so I think now we are at NFS v5 or v6, I forgot. But generally, NFS was created by, it's a protocol created for Linux and Unix environments based on the same client-server environment. But compare NFS and CIFS. Some people say NFS is less secure, but faster, right? It is generally faster because of how it works compared to CIFS. But yeah, it may be a bit less secure in some sense. CIFS is more secure, but it's very long, so many steps. You have to open the tree, you have to open the tree connect, send the session, transfer the data. Finally, after transferring the data, you have to say, okay, I've already transferred data, can you disconnect my session? So there's so many things to talk to in between. Whereas NFS is just open a remote procedure call. The remote procedure call reaches the server. Once it reaches the server, it opens up the channel, sends back to you, you start transferring data, much more faster. But yeah. Okay, any questions?
Yep, I have a question about this protocol, about NFS protocol. Have you ever compared the performance NFS protocol on Linux and Windows Server?
Yes. Generally, NFS is faster.
Oh, no. My question is, have you ever compared the performance of NFS on Linux operating system and Windows Server?
Oh yeah, you can install NFS on Windows. So you just have to download the utilities and all that. It generally still runs faster if you compare NFS on.
I actually in my institution I have an HCIA Store Easy. You know, HCIA Store Easy. The operating system uses Windows 2012.
Okay, that's pretty old. Yeah.
Yeah, HCIA Store Easy. Actually, when I try to run NFS server under the Windows server, the performance not so fast compared to the Linux server. I don't know why, because it looks like the NFS server under the Windows server looks like not so fast compared to the Linux.
That is very easily explained, sir. Windows, is still running Windows 2012?
Sorry?
You're still running Windows 2012? You're trying to connect from Windows 2012 to 2012 or 2010, 2020 to 2012?
2012.
Okay. So first of all, the problem is the old Windows servers, the old 2012 servers, they have a lot of overhead. They have a lot of processing data, right? So if you go to open your CPU and stuff, you see your memory being eaten quite a lot, right? So that is already an issue with Windows servers. Even if you do CIFS share will be very slow. right? It doesn't matter if you do NFS or CIFS, it will still generally be very slow because of how the architecture of 2012 is. Okay.
Okay.
But maybe you want to increase the RAM and change the Windows version, sir.
Yeah, I try to tuning up the Windows registry, but still I found the best performance of the Windows server. Okay, you can.
No worries. But generally, yeah, we try to stay away from 2012. Because 2012 has there are certain known issues regarding the memory. This one, they eat a lot of memory for their back-end processes stuff. Even compared, like the newer Windows, we already know they eat a lot of memory, so we already tend to buy a lot of memory for that. But the older ones, if you have a lot of back-end applications running, you might want to check your services. So which services are up, which services, you have to go through the services list, see which you need and which you don't need, and then shut down those services. It takes some time, but yeah, those are Windows machines, man. What to do?
Yeah, I know. Okay.
No issues. But just double check on your services, what are running, what is not running, what is eating up your memory and CPU.
Okay.
So when you do the share, you try to open up the task manager and all that. If you have like a syslog and all that, double check. So what is eating up the resources? So that is NFS protocol. Still uses a client-server architecture. Generally still faster in some sense compared to CIFS. Then we talk about NDMP. So NDMP is only found on file servers. NDMP, or Network Data Management Protocol, is used to do backups for file servers. This is the protocol that they use to do backups for file servers, right? It's the only way they do backups. So NDMP is this NDMP protocol, or we'll put the full protocol here. Network Data Management Protocol, right? So NDMP is used for designed to do backups for file servers or file systems, NAS devices, network attached storage. So it enables NAS devices to directly send data to the connected disk devices or backup servers on the network for backup without any backup client agent required. This is what they call, I think this will be the server-free architecture. Later when we go into backups, you'll understand that one. So backups, you can have either a two-way backup or a three-way backup, depending, no issues. But NDMP is only used for backup in NAS. That is the protocol. So if you want to do backups for NAS, you have to use NDMP. There are other ways to do it, but generally we try to use NDMP. Eats less resources. Okay, and that's it. Okay, any questions?
Is it also proprietary from Huawei, this protocol?
Sorry?
Is this protocol proprietary from Huawei?
No, this is a general protocol.
Oh, general protocol, open standard.
Open standard. So it's for any backups you want to do on NAS, you'll use NDMP. No issues.
Okay.
No issues, sir. Okay, so some questions. Which networks are included in FC topologies? Anybody can tell me? No worry, don't be shy.
Bitrate
A, B,
and
C.
All right, that's correct. There is no dual switch network. So arbitrator loop, point-to-point, and switching network, yes. PCIe, what is the current version currently available?
PN4.
Very easy.
All of them.
All four, right?
Okay.
No issues. Do they still have questions? Okay. So which of the following are file sharing protocol? This is a very, very deceptive question.
Clearly, it's CND.
CND.
I do with A and B. A may be, but I'm not sure.
Actually, HTTP is also a file sharing protocol.
If that's the case, then B. Then so is B.
This guy is not a file sharing protocol.
Yeah.
So it's ACD. HTTP is a file sharing protocol.
Oh yeah,
right?
HTTP files.
So which of the versions of NFS are currently available? Yeah, you have
all of them.
all of them. So this question actually came out from my exam.
Okay.
Yeah, so just telling you, this is the exact question that came out from my exam. Which other processes are involved when CIFS protocols is used? This they don't tell you, but yeah, okay, I will tell you. First, you start off with a protocol handshake, then you do a security authentication, then you do a connection to the file share, or what they call the tree connect. So this is what they call the tree connect. Right? Then you do your file operation, and then you do your disconnection. So all fine. These are actual processes, so step by step. So step 1, step 2, step 3, step 4, and step 5. If you go under CIFS, you'll find all these 5 steps. Right? So the answer is A, B, C, D, E. So in summary, we have covered all the common storage protocols. So we have covered Skazi, we have covered Skazi, Fibre Channel over Ethernet, serial attached Skazi, SATA or serial ATA, peripheral component interconnect express, non-volatile memory express, remote direct memory access, remote direct memory access over centralized Ethernet, InfiniBand, IWAP, Common Internet File System, Network File System, and Network Data Management Protocol. So we have covered all these guys. Okay. Some more information can be found here. Some recommendations, and thank you. So any questions from you guys?
No.
Cool. No worries. All right. So then we will take a short break. The current time will be 2:30 for you guys, correct? 2:31. So let's just call it 2:35. So I will give you guys, do you guys want a 15-minute or 20-minute break? Up to you guys. Guys?
Okay. 20 minutes?
No, it's all right. I mean, it's democracy, man. We ask for what you want. So so we'll be back at 2:55. Is that all right with you guys?
Yes. 2:30.
So now it's
okay, 2:55, yeah.
2:55, right? Plus minus.
Yeah.
Okay. So have a good one. Rest yourselves up, and we'll see each other shortly.
Okay, thank you.
Thank you. All right, guys, we are back. So we'll start off with the next chapter. Hope everybody's all right.
Yes.
So, yeah, no issues there, no issues. Let's see. Maybe we can take a lighter chapter because this chapter is a bit, yeah. Maybe we'll take a bit lighter chapter. So we can end, yeah, if we finish this chapter, so I'll do chapter 2.5, which is module 2, chapter 5. Tomorrow we can start off with, we'll finish the last part of module 2, chapter 5, and then we'll go to module 3. I mean module 2, chapter 4, and then we'll go to module 3. So if all goes well today, we can finish class a bit early to give you guys time, more time to do your own work and stuff, right? No issues there. I just double checked. So we are on track, no issues, no problems there. So I will go into module 2, chapter 5 first. I will skip module 4, chapter 2. I mean on module 2, chapter 4. Tomorrow we'll go into module 2, chapter 4 because that's, yeah. I also think it's better to understand the network architecture first before we understand all like the controller architecture and all this stuff, right? So we just went through protocols. We are going to storage network architecture. So with the development of host, disk, network technologies, and storage systems, the architecture evolves. And the storage network architecture also develops in some sense to meet these requirements. This lesson introduces the storage network architecture. Upon completion of this topic, you will be able to better understand storage network architecture evolution and storage networking technology evolution. Content-wise, 4 things to go through. So we'll go through DAS, NAS, SAN, and distributed architecture. So we'll start off with DAS. So what is DAS architecture, right? So it's a pretty simple one. It's a pretty simple one, sorry. For some reason I paused the share or something. So DAS architecture, you have basically 2 different types of DAS architecture. You have external DAS, external DAS and internal DAS. Right? So external DAS, you have also 2 defined architectures, which is basically external DAS with just disk arrays, or what they call JBOD, and also smart disk arrays, right? Which basically calls controller architecture, right? Internal DAS is very similar to your laptops, right? Your laptops, your desktop, and all this stuff. Anything that you have internal storage, right? So we start off with external, internal DAS, we have nothing much to talk about. So internal DAS is just like you have a server, and inside the server you have multiple disks. So you have disk 1, disk 2, disk 3. So that is internal DAS. Whatever storage that you find internally inside your server, that is counted as internal DAS. External DAS is anything outside of your server. So if your server connects to a disk array, or if your server connects to a what do you call this, storage environment or something like that, that is an external DAS product. Okay, so simply saying in this sense, sorry, the 2 types of products that they show you here are basically external DAS, which is with just a disk array. So it's a simple architecture. Basically, you just have your server connected to extra disk. That's it, right? Just extra external storage, right? The external storage is just storage, does not have any compute functions, does not have any, let's say, management functions and stuff. Then the other type of external DAS is called a smart disk array. Smart disk array is basically your basically attaching a server to a storage controller, a single server to a single storage controller. This kind of, I have seen this kind of topology in small companies, but yeah. So we shall talk about both of them. So usually for external disk array architecture, when you attach a server to, let's say, more disks, more disk arrays and all this stuff, just a bunch of disks, you will require to use some kind of RAID card. So you will be forced to use some kind of RAID card on the server, or if you have a software RAID, something to do with the RAIDs on the disk environments, right? So you'll establish like RAID 1, RAID 0, using either a physical RAID card or some kind of RAID software. That is the difference between this guy. Smart disk arrays, basically all the RAID configuration is done by the controller itself. So the controller is then going to configure your RAID, is going to configure how your files are being saved, all that done by the storage controller. So in most sense, if you want to use a DAS architecture, this is the appropriate architecture to use. Why? The server can then just cater for its own application and all this stuff. So whatever application and all that it's running. And the storage controller can then substitute for other processes like storage processes, where to save the files, where to locate the files and all that. That's done by the storage controller. However, it is definitely generally 2 or 3 times more expensive than this architecture, right? Any questions? Cool. Right. So that is external disk array and smart disk array. That is basically the DAS architecture. Really nothing much to talk about, right? However, yeah, when you come to about advantages and disadvantages, there are certain things we talk about first. So challenges for DAS. First of all, low scalability. Why? Limited port numbers. So a server can only have certain amount of ports, right? Once all those ports are filled with disks and all that stuff, yeah, you cannot expand anymore. There will be a definite fixed amount of number of disks. Limited number of addressable disks. So using its own processing power and all that stuff, it can't cater for everything at the same time. It is going to cater for the application, it's going to cater for the disk problems. And DAS also has a distance limitation, right? So what is the maximum distance you can do with a DAS? 100 meters, right? Ethernet cable, plus minus. Fibre channel, maybe a fiber cable, you can do a bit longer here and there. But generally there is one-to-one device distance limitation, right? Compared to like switch network and all that stuff, or SAN network, you can scale a bit further, much more distance, because you have switches to then redirect the traffic and then yeah, all this stuff. But if you're doing a one-to-one connection, you have certain distance limitations, right? Maintenance problems, inconvenient maintenance. So if you want to do maintenance on the storage, you're basically going to shut down the server, right? If you keep the server running and all this stuff, yeah, basically the whole system will be affected during any maintenance, right? So you're going to maintain the storage, the server is going to be affected. You're going to maintain the server, the storage is going to be affected. So there's no way around it because it's one-to-one connection, right? However it is, something will go down. People cannot locate their files and all that for that maintenance window, okay? So system needs to be powered off during maintenance, which is a problem. Insufficient resource sharing. Generally, because it's a one-to-one connection, the server is connected to the storage. Whatever amount of storage that the server can grow, whatever amount of storage the storage controller can go, that's what you get. It is not sharing resources with any other servers. One-to-one, right? So front-end ports and storage space are difficult to share. Resource silo problems. Resource silo is something like this. So let's say this is, let's just say these are 2 devices that you have on your LAN. So you have a LAN network connected, and of course you have some users here and all this stuff, right? No problems. Okay. So you say this whole storage has been used. So it already reached its maximum, right? You cannot share storage with this guy. This is what they call a resource silo. It's a silo on its own. It's basically a product on its own, right? They cannot share resources with other storages. if they want to share resources with other storage, they should have a connection between the storages and stuff. This is not the case for DAS. DAS are resource silos. So if this guy, like say, only has 50% utilization, this guy has 99% utilization. So only way is this guy has to delete off his own data. Because they are not sharing the storage device, they are all separate from each other. That is a problem. This is a resource silo issue. Okay? And also for maintenance, right? So if you want to maintain the service, let's say you have 2 DAS devices, no problem. You come inside, you are the user, you do maintenance. You have to log in into the server to do the maintenance for the storage. Do you realize that? So even in this smart disk array, the storage controller is not connected to the LAN. It's connected to the server. So you will use the server to connect to the storage to do maintenance. And if you maintain the storage, you bring the storage down, right? You do some kind of maintenance and all this stuff. Basically, the server application cannot access the storage device. Or if you want to do maintenance for the server itself, right? So you want to do maintenance for the server. If you bring the server down, basically users cannot access the storage, right? Even though the data is still there, the storage controller is still up, but they cannot access the storage. This is the resource silo issue, okay? 2. So, for example, the DAS with insufficient storage space cannot share the space remaining with the DAS with excessive storage resource. This is the resource silo problem here. These are the certain challenges you will find for DAS. And that is DAS. Nothing much to talk about. Why? Because it's a one-to-one connection, right? It is not like some massive interconnected network or something like that. So next we'll go into network attached storage. This is where you kind of have to understand certain theories here and there. Okay, so what is network attached storage? So network attached storage basically is set on the live network. So it's actually based on your LAN connection. So you'll see this topology here. You have multiple servers connected to a switch and the switch connected to the NAS device. This can be all on your LAN, right? This is basically your LAN network. Why? The NAS device can contain an IP address. So you can set an IP address on the NAS device, and using the IP address, you can then connect to your file server. Excuse me. So yeah, so you can connect to your file server. Once you're connected to your file server, then you can access your file server and get the files, depending on what kind of course, protocol you're using. So if you're using Windows, you'll use CIFS generally, usually. But nowadays you can use NFS also, doesn't matter. You can download the utilities, no problem. And if you're using Linux or Unix environments, you usually will use NFS, right? So sir, yes, the question just now you told me that you still have issues. What version of NFS you're using also does matter. So if you're using like an older version of NFS, 2 sites are using one older, one newer, you might want to upgrade NFS versions and stuff. Make sure you download the correct utilities, right? So you might want to check all those stuff. So depending on what kind of file system you're using, yeah, you then connect it to a switch, get connected to the IP. You, if you're a Linux environment, you probably mount the file system. Okay, so you'll mount the file system. Once mounted, then you can, of course, achieve your file system and stuff, right? You can go and access the file system and all this stuff. But generally, because the NAS device has an IP address, theoretically, you can connect from or connect to the NAS device from anywhere. So as long as there's a route for the IP address to go to the internet, maybe, so you put it on the internet somewhere, as long as the IP address, maybe there's a public IP address, so people can access the public IP address, right? No problem, because it's IP based, right? And another thing is concurrent file sharing. So you can see here you have 3 different guys. So maybe we are using an NFS file share, right? Even though this is a Windows system, he installed NFS utilities and all this stuff. So it's all using NFS, right? So let's just say in that scenario. all these three servers can concurrently access the file system at the same time. So all those three guys can access the file system at the same time. Of course, in this scenario, if it's all 1G, 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 you'll have some kind of bottleneck here. So might want to do like some kind of a ether channel or something, make it like 4G or something like that, right? But this can be easily done with NFS. Concurrent requests, right? Concurrent access, improving the efficiency of your storage so much more people can access the storage, improving the flexibility where you can access the storage from, centralized storage, so it's one environment for the storage. You use an IP address. If you have like a NAS gateway in that sense, that's quite cool. So the concept of a NAS gateway is like you have multiple NAS devices. They all share a similar, like a, let's take a domain name. So they share a similar, like a www.nas.com/NAS or something like that. So as long as anybody can access the www.nas.com/NAS, they can access the file share, right? And also, do you have some kind of security whereby you can have account management? You can have certain people only access the NAS and can download files. If they don't have the appropriate account, they cannot access the NAS file system. This can be easily done in Windows using Active Directory and in Linux using like local user and all these things, right? Can easily be done. High availability, high scalability can also be done on NAS. But of course, high availability, you will require at least 2 controllers or 2 NAS boxes. So Huawei devices come with that, so no problems. High scalability, because of how we use the RAID 2.0 block virtualization, you can scale the NAS file system size, no problem. You can scale up, right? So that means you can increase the size, but you cannot decrease the size, right? And yeah, finally, security there. Simplified management, everything is under GUI in NAS. Usually, last time everything is CLI, but nowadays everything is usually in GUI, so no issues. Huawei's devices all use GUI. Generally, to set up the whole storage in Huawei, we use GUI. You can use CLI if you want. If you're more familiar with CLI, go ahead. But we tend to use GUI to make things or make our life easier, right?
GUI, it means using web application?
Yeah, web application.
Okay.
Like using the browser and then just connect to it and then yeah. No issues. So rather than using the command line, we use the graphical user interface. That's it.
For the command line, is it use such as Linux command or BSD command?
It's under something called EULA OS. It's Linux, EULA, yeah.
It's derived from Linux?
Yes, it's derived from CentOS.
Oh, CentOS, okay.
So EULA OS is Huawei's distribution of Linux. So it's basically CentOS, but Huawei took it and then changed some stuff here and there, right? Right. So general purpose server and NAS device. So you'll see the differences here between a normal server and a NAS box, right? So a normal server, you'll have your application, you'll have your printer driver, your file system, your OS, the network, and all this stuff. So you have a lot of processes running on your normal server, right? So to want it to do the file system product and all that stuff makes, well, it's basically going to use up the CPU memory of the server itself. So what NAS is basically, if you put it in a better term, it's an optimized file server. Okay, so that's basically what a NAS is. A NAS product is an optimized file server, whereby you still have a file system, you still have an OS and a network. Why OS? Because you need to know what kind of file share you're running. So either you're running CIFS or NFS, you need to know what kind of file system, what kind of file share are you running, right? The file system concept is basically very simple. Normal servers do have the file system. The file system is the one that describes how your files are saved, folders, documents, and all these things. what kind of document is it saved as, where is it saved as, all that. So usually if you don't have a NAS box, the server does it on its own. But if you have a NAS file system, the file system on the NAS does the basically the categorization of the files and folders and stuff, right? So it alleviates all these processing features from the server. So that's why they tend to call it as an optimized file server. Then generally you also have to have a network, else you won't have connection, right? So this is basically the differences between a general purpose server and a NAS device. So a general purpose, like your normal file server and all that stuff, generally it's just a file, it's a server running a file system with some applications and all that. The NAS box is optimized to just run file sharing, right? Any questions? Cool. So that's the difference between general purpose server and NAS boxes. So you don't have to think or go very deep into the product and stuff. It is an optimized file server.
I have a question.
Go ahead, sir.
Okay. If a NAS device to be installed with the application, is it possible or disabled? Impossible.
Usually you don't install, you cannot install applications on a NAS device.
Yeah.
You can, however, copy the whole application over and leave it as a file there. So you can access the application from the NAS device, but the NAS device, you don't install the application on top.
Okay.
Right? So that's NAS and versus general servers. Okay. So what kind of protocols does NAS use? Of course, as usual, NFS for Unix and Linux, CIFS for Windows, and you have also file transfer protocols, HTTP for file access, and NBMP for backup, right? So you can run all these protocols. Generally, you will only run either NFS or CIFS. If you want an FTP to the server, FTP server is also counted as a file server because there are files inside the server, you're downloading files from that server. So it can be a NAS box also, right? How it works, similar to how we talked about how storages save files. So basically all the enterprise servers will connect either via CIFS or NFS, depending on which kind of file share. Enter the file share or the file system in the NAS box and locate which files are there. Okay, so if the files are already saved, if they are doing a read, so let's say we are doing a read, right? So read, they will come inside the file system. They will talk to the file system, and the file system will say, okay, your file is located in this pool. So you just go to that pool, you read the resources, no problem. When you're writing resources, or when you're saving a file into the file system, basically you contact the file system, you save the file into a cache, right? Once this is done, as usual, once you save file into the cache, the file system will tell you, okay, you can go away now. Your job is done. You saved the file. And then it will flush the file into the storage pool, right? So this is how it saves files. Reading files different, saving files different, okay? These are the protocols. So you kind of just have to remember, the only one that is a bit new is NDMP, but that's only used for backup in file systems. Okay, NDMP is only used for backup in file systems. There are no other, or there's no other purpose other than that. Okay. Any questions? Let's see how many. Okay. Cool. So now we'll look at the different types of file system, NFS, CIFS, and all this stuff. So NFS works on something called RPC. Okay, so working principles of NFS. So you'll have some kind of NFS client program. The client will send a request, which is what they call an RPC. An RPC is actually called Remote procedure call, right? So the client will send a RPC request to the server, right? So the server will get the RPC request. It will then check its port, it will map the table. So what is the request, where is the file mounted, and what is the share information. So once it gets the request, it will say, okay, it will double check your share information, what username and password you've used to log in, or what directory can you access and all that stuff. That is all set on the file system end itself. Once you're done with the registration, you'll send a response back to the guy. Okay, you can start your file share. So then you start your file communications. You go into the mounted drive, and then you download whatever files or share, read whatever files you want. No problem, right? And then once you're done, you can just leave it. Okay, that's how NFS works using remote procedure call. It's only 3 steps. Request, response, and then you start the communication. You send the request to the server then ports, checks the mapping table and all that stuff. If you have permission, if you have your account is registered and all that stuff. If your account is registered, okay, send a response. Okay, you can start your communication. Once the communication started, you can just go inside. Basically, it'll be a mounted drive already. So once it's mounted, you can just access the share, go inside, do whatever you want, and then go out. No issues. It will always be connected in some sense, right? Once mounted, it's always connected, right? For Linux clients or Unix clients. That's on NFS. Typical applications of NFS, basically in cloud computing or in a cloud service environments, generally we tend to use more NFS than CIFS. You have a choice, but we tend to use more NFS because we want things to move faster. Because cloud, as you guys know, connecting to the cloud, if you have a bad connection, it's up to you. Inside the internal network of the cloud, it will be fast. But it's your connection to the cloud, right? So generally, that's how it works. So main purposes now, you'll see much more in cloud computing, right? So cloud computing uses NFS servers as an internal shared storage. This is by standard Huawei Cloud, AWS, and so forth. You got Google and all these guys, except for like Microsoft Azure. Microsoft Azure uses CIFS as their file sharing protocol by default. You can, however, change it to NFS, so no issues there. CIFS. CIFS is, let's say, a very long protocol. So there are 5 phases. So first phase is what we call the protocol handshake, right? So the protocol handshake is basically when the client starts the negotiation, sends a negotiate request to the server, say, okay, this is my protocol. I'm coming inside using CIFS. Can I access the file share? So they say, okay, your protocol is accepted. All right. You should be able to, all good. Then the client sends back a session setup. So session, okay, can I start the session now? Server will then reply saying, okay, yeah, you can start your session. I've got your account ID, all these things. So this is where you put in your account, right? So here is like, okay, we are using CIFS. Okay. Once that is done, once the session, security session, authentication and all that is done, then you'll open the tree connect. The tree connect is checking, okay, from your AD or all that, or Active Directory, what files can you see? So using Active Directory, you can specify certain users can see certain files, certain users cannot see certain files. So that's why you open your tree connection. The server will check for the NFS server or NAS server, will check on its end, okay, this guy has come in with this account, so I should give him access to these files, right? So the client has to send the request first. Connect request, then the server will respond, then you start saving or deleting files here, okay? You want to put in files, you want to remove files and all this stuff. That is done on the file operation sequence. After the file operation sequence, you have the disconnection sequence, right? So you can see here 5 different steps. you have the protocol handshake, you have the security authentication, the share connection, the file operation, and finally the disconnection. This is how generally CIFS works. You have to go through all these 5 requests at the same time. I mean, to open up a connection. If you open up like Cloud Shark or something, probably you can see it. Let's see if you can find it in Cloud Shark. Okay, maybe this guy. Okay. So this one, yeah, this one basically everything is going wrong here. So it's just sending error messages. This one nothing much to see. Let's see if we go CIFS here. Okay. So CIFS, yeah. The thing is, you can't see what's happening in the CIFS. So you can see here it's a negotiate requested by dialects. What can you see? Here, this is the SMB, second SMB. The same negotiation. Okay, you can see some other stuff. So this is when negotiation happens. There should be a lot more open. So first will be your TCP, open up the session. Then you negotiate the protocol, and then you get a response, and then you negotiate the security and all that stuff. Then you open the tree connect. So there will be multiple layers. Just to open one connection or one session, yeah, it's not easy, right? It takes a while. It's generally much more slower than NFS. But some people argue that it's much more secure. It's true in a way, but yeah, okay? But you have to remember, the only thing you have to remember for exam is these 5 things, right? So you have to remember the protocol handshake, the security authentication, share connection, file operation, disconnection. They will usually ask the question, okay, what are the 5 working, or what is the working principle of CIFS, and so forth. You've seen the question earlier on, so it can be the same, okay? Any questions you guys have?
Sir, how about we compare with FTP, which I know FTP have a same lot of connection first.
STP is, yeah. Are you talking about FTP or STP?
Yeah, I mean FTP, file transfer protocol, about the performance, the CIF and the FTP, which one will be the good?
Well, FTP has 2 different ports actually. FTP will be port 20 and 21, right? So 21 they will use for authentication, and 20 will be for the file share. So if you open up FTP, this is what you'll see. FTP.
Yeah.
Layers. Okay. Let's see if they have any here.
Yeah, I mean, when we use FTP, they use control protocol first. First they use TCP first. After TCP, they use control protocol first. After that, data will send. So I see the similarity with this CIF.
Yeah, it's a bit similar, but it's a bit more faster actually. Why?
Which one?
Basically, FTP is a bit more faster. Why? Because you use port 21 first. So you'll start off with port, let's put it here. Okay. So you'll start off with port 21 for your control protocol or your control process. So this will be on port 21. This will be on port 21. Once the control process is done, then you use port 20 to transfer data, right? So the request, and then this one is only like about 4 levels. Like if you send a request, I want to open a control for FTP. The server replies, okay, your control protocol is accepted. Then you start the data transfer. That's it, right? So it's not as tedious as CIFS, comparable, right? Make sense?
Okay. Makes sense. So if we just use to file sharing, FTP will be the best, yeah? More.
Okay, well, can't say. I would still prefer NFS at the end. I mean, I'm an NFS advocate, but FTP less secure.
Oh yeah, I mean FTP compare with the CIF.
CIFS, right? So FTP
CIFS, yeah.
generally is still less secure than CIFS.
Oh, less secure. Okay.
So if you want to talk about security, yeah, CIFS generally is much more secure because you have so many sessions open. You have to know all the client ID requests, everything. So yeah. Okay. Any other questions? Cool. So typical application scenarios for CIFS. This is a typical office environment. So what you'll have, of course, your clients, your domain name servers, and your Active Directory servers, right? So if clients want to access the file share, what will happen first? The clients will check with the domain name servers, what is the Active Directory, so what is their AD, and then they will try to connect to their, NAS via URL or something, right? The NAS will then check with the Active Directory server whether this is during the security authentication, whether the client is allowed to access the NAS servers or not, right? So you can see the authentication flow, management flow, no worries, but the authentication flow, the authentication part has to be done first, then the client can send data, right? So it will use the Active Directory for authentication. So if your Active Directory states that this user, this Mac user cannot access the file share, then he cannot access the file share. But if he says, okay, this Windows user can access the file share, or this normal Intel user can access the file share, then he can access the file share. So Active Directory basically governs who can access or who cannot access the file share. So it's much more easier in some sense to set up, if you do it in the right way, you'll have very, very good access and all this stuff. But most of the times people screw up their AD service, right? I've seen a lot of companies whereby they just keep adding and adding more AD data, opening up new kinds of profiles and all these things. So yeah, but if you set it up properly, actually a Windows environment is all right, but it must be set up. You must really have a good Active Directory administrator or server administrator in that sense. If your server administrator is a bad guy, just tries to complete everything fast, yeah. Because if you set it up once it's set up properly, your Active Directory profile will make a lot of sense. It will actually be very easy to cater for later on. So you need to set up all the profiles properly first, make sure what connections they have. After that, then yeah. But if you just do it in a hurry and all that stuff, Active or AD forest can be a mess, right? But this is generally how CIFS works. So you'll have your authentication flow and your data flow. The authentication will be done first, then you can send your data over the LAN environment, okay? Of course, management-wise, you can connect via IP to the management. You should have a management IP for your NAS server. You can connect to the NAS server, put in the password and all these things, and then access the management network. You want to do performance monitoring, system management and all that. That will be on the NAS device itself. So the NAS device can be any NAS device. Can be a Huawei NAS device, can be a Huawei Ocean storage product, can be a NetApp, Synology, anything, right? Usually they all can run CIFS, they all can run NFS. Maybe NFS different versions, but yeah, they can basically run the protocol itself. So this is a typical file sharing scenario in Microsoft environments. Okay, so you guys are more with Microsoft or Linux in your universities? Mostly Microsoft, right? Anyone?
I don't know exactly because there are some department who manage the network.
Network guys, but generally they still use Windows desktops, right?
Oh yeah, for desktop we use Windows.
Yeah. So I actually taught a class in South Africa. It was a company, and it was a full Linux company. Oh, that was a hard class to teach, man. They were basically massive professional guys. They know all the Linux environment stuff and all that stuff. So yeah, I think we only finished chapter 2 in day 4, I think. So they had a lot of questions and stuff. So no issues. But don't worry, if you're a Windows environment, doesn't mean it's a bad environment. If it's set up properly, it's good. If it's set up badly, then you'll have issues. Linux environments are much more faster because there's less things to configure. You don't have Active Directory, you just have local passwords here and there, maybe accounts here and there, yeah. Also nowadays, I think Linux also has GUI interfaces. So yeah, maybe in the future we'll be seeing more Linux stuff. And I see a lot of people actually moving to ARM chipsets. So like Huawei is already moving to its Kunping ARM chipset, which is a RISC type chipset or RISC. We are moving away from the Intel CISC based chipsets, right? Slowly. If you're still using Windows, then yeah, Intel chipsets still must be used. If you're using ARM, then Linux chipsets, all right, not bad. Even AWS is slowly, generally people still use Windows, but just for desktop support. Servers and all that, people still use Linux environments. I will never know. Why? One reason I can tell you, main reason why people try to move away from Windows, licensing costs. Licensing costs in Windows can kill you, man. Very expensive, the licenses. But it's still cheaper compared to Oracle. Any of you run Oracle databases? Nobody? Or I don't know. No issues, no issues. Why I brought up Oracle is this, because previously before this, we wanted to do a migration project for one of the companies. They were running an Oracle database. They wanted to migrate from their on-premise to the cloud, and they also wanted to migrate their Oracle database to the cloud, which is all fine and it's good stuff, no issues. We were like, all right, no problem. Then we found out the licensing cost for Oracle. Oracle's licensing is depending on server cores, right? So if your server has 20 cores, right? So if your server has 20 cores, per core, guess how much is the Oracle license? Their Oracle was a top-end guy. I don't know I forgot what kind of license they have, but they have like the top-end features and all this stuff. Just try to take a guess in USD, how much per core license? Anyone? Just try to take a guess.
$10,000 maybe.
10,000 is cheap, man. Yeah, 10,000 is cheap.
50,000?
50,000 is still cheap.
What? Spill the beans.
Per core was 112,000 USD.
Cores.
Per core.
So if we are having, let's
20
say...
cores? Yeah, times 20, man.
Okay.
Yeah. So that project was cancelled because it was just too expensive. We just told them, man, if you want to migrate, go to Oracle Cloud. I think it's cheaper there. Because if you want to migrate to AWS and all that, you want to bring like Huawei and all that, you want to bring over the licensing. Oh, crazy stuff. You already had issues with Microsoft, right? Microsoft, you want to migrate from on-site to the cloud. You want to migrate all the license. Yeah, it came up to about extra 20, 30,000 because of license. But Oracle, now we don't touch Oracle at all. After that project, we just said, stop, no more Oracles. The moment the person says, I want to migrate Oracle database to the cloud, yeah, my organization, my company just backs out. Because it's too expensive, crazy stuff. I don't know what kind of license was that, but they did the calculation and gave it to us. So it says like every core, so they needed to know how many cores. So we told them like, okay, you want what kind of server? We were proposing to them like high-end stuff. They say like, oh yeah, 23 cores, very powerful. They pay this much, and the company was like, yeah, it's very powerful. We're much more faster than what we have. Then they came with the license. 112,000 per core, man. USD. Oh, crazy. And the whole project, if we did the whole project, we only get a small cut. Like, I think we get about like, finishing the whole project, I think we get about like 5,000 USD or something, right? But if anything goes wrong, my company bankrupt straight, man. If you mistakenly move the license or something, so we said, no, we don't want to take that project and stuff. Crazy stuff, man. So yeah, licensing will be a problem if you want to move to the cloud. Just telling you guys. All right, so that was NES. So now we'll move on to SAN. I think it should be all right. Yeah, SAN. So I think if we finish this, then I can let you guys go a bit earlier, so no issues there. So we'll go into SAN first. So first we'll talk about IP SAN, then we'll talk about FC SAN. So IP SAN is what they call Is Crc, right? So here we're straight away going to the NIC and all that stuff, but before we start that, so IP SAN, generally the protocol you use is ISCSI, Is Crc, right? Is Crc is the protocol used in IP SAN. For FC SAN, you'll use FCP, Fibre Channel Protocol, right? Two differences. Yeah, any questions, sir? No issues? So yeah. So to use IP SAN, basically you have multiple choices on the NIC card, right? So first one we have here is what you call the NIC plus initiator software. So this is just your normal network interface card. So you just buy a normal network card, plug it into the server, Ethernet, plug it in, no problem. Problem is, if you want to use something like this, you will have to download something called an initiator software. The initiator software is the one that helps you convert the Is Crc packets into Is Crc, I mean the Scuzzy packets into Is Crc PDUs and then into TCP IP packets. So it has to do both the conversions here, Is Crc and TCP IP, right? So it will use up the server resources. Basically, you install it in the server has to use its own resources to make sure that it can generate Is Crc PDUs and TCP IP packets. And then finally transmit it over the IP SAN network to reach the storage device. This is only if you use NIC and initiator, just a normal network interface card, right? There is, however, a second choice, which is using something called a TOE NIC, right? A TOE NIC basically is called TCP offload engine, right? The TCP offload engine generally only does TCP IP conversions, right? So you still need the initiator software, but the initiator software has less work. So previously it has to convert Is Crc PDUs and TCP IP packets. Now it just does the Is Crc PDU conversion, right? Okay, so this is if you use the TCP offload engine. Okay, still taking up some resources because they need to convert the Is Crc PDUs. Not as much as the previous guy, but still there. Okay, if you want to run IP, yeah, this is one of the second choice. And the most expensive choice is using something called an Is Crc HPA, but also the most best choice. Why? Because you don't have to download any kind of software. The Is Crc HPA is the one that converts the Is Crc packets into Is Crc PDUs and TCP IP packets, right? So it does the full conversion. This one card does the full conversion for you. You don't have to use the resources on your server itself. Okay, so Is Crc HBA card or host bus adapter card will be the one that does the conversion for you. So the full form is, okay, the full form is internet. Oh, sorry, for some reason isn't typed. So this is the full form of Scuzzy HBA. That's why they created a short name for it. Scuzzy HBA is Internet Small Computer Systems Interface Host Bus Adapter Card, right? That is generally this guy. So it will be generally a bit more expensive, but most people would rather spend a bit more money and save the CPU and memory on their servers. So their servers can do some other things, rather than their servers spending more resources to convert the packets and all this stuff using certain software. Okay, so this is usually the default selection if you're going for Scuzzy. However, if you want to go with a cheaper method, maybe you don't have the budget and all that, you still can use your network interface card. You just have to download some kind of Scuzzy initiator software. Okay, and then you can send your packets over the IP network using IP SAN network. No issues. Okay. So here is a logical port. So logical port, they're talking about VLANs here, right? So you can bond the ports and all these things, right? So you can create like an Ether channel, Ether connection and all these things. So logical ports are created based on bond ports, VLAN ports or Ethernet ports. Logical ports are virtual ports that carry host services. A unique IP address is allocated to each logical port for carrying its services. Okay. So you'll see here. So number one here is bond port to Ethernet port, indicates multiple Ethernet ports are bonded in a form of a bond port or Ether channel. You're more familiar with the term Ether channel, that's what they're doing here. Number two, basically Ethernet port to the VLAN here, indicates that an Ethernet port is added into multiple VLANs. Number three, the bond port to VLAN, so indicates that a bond port is added to multiple VLANs. Number four, bond port to logical port, so indicates a bond port used to create a multiple logical ports. Number five, VLAN to logical port, indicates VLAN port to create multiple logical ports. And number six, indicates Ethernet port used to create multiple logical ports. So there are multiple different types of ports that you can create it, but generally it's standing from either bond ports, or you use logical ports, or you create some kind of VLAN on top of the port itself. So depending on your organization, most organizations use VLAN to segregate their servers. So production VLAN, management VLAN, and all these things. No problems. That can still be done on the Scuzzy end also, right? You'll create your own production VLAN, you put it on your LAN and all this stuff. And then you segregate one VLAN for servers, one VLAN for storages, create it that way. No problem. Because an Scuzzy connection basically runs on VLANs, basically runs on your Ether network or Ethernet network. So you can do all these things, right? Any questions? Cool. VLAN configuration. So here is basically how they divide different ports into a certain VLAN. So you can say like maybe this is the management port, MG and T. This guy will be like the serial port, or maybe this will be like the maintenance port, and this will be like your production port, right? So you can bond VLANs to the port directly, right? So they'll say only if you're coming in from VLAN 1 can you go into the management port. So you need to know how to access VLAN 1, what is your IP address and all the stuff for VLAN 1. Yeah. If you're coming from VLAN 2, you can go into maintenance port. If you're coming from VLAN 3, for some reason, you can also go into management, just putting it out there. But yeah, you can do something like this. So this is basically a bond port. So you're bonding these two, maybe it's a 1 gigabyte, 1 gigabyte. So they're basically you're bonding 1 gigabyte ports to form one Ether channel that is 2 gigabytes in length, right? So you can do something like this via VLAN. There's multiple ways where you can bond using a LACP or some kind of bonding. No issues there. Generally, I think we use LACP a lot. So yeah, VLAN bonding not a problem, right? So I think we all kind of understand VLANs. probably you preach, you talk about VLANs on a day-to-day basis in your classes. So yeah, I think VLANs is a simple thing to understand. And then if you understand VLANs, you will probably also understand what an IP address failover works. So IP address failover, usually what we'll do is we'll assign a logical port to a bonded port. So when you want to access that port, you just use the logical IP. Hence, if any IP address fails, you can just failover from the faulty port to the non-faulty port and stuff, right? So IP address failover indicates that a logical IP address fails over from a faulty port to an available port. In this way, services are switched from the faulty port to available port without interruption. Faulty port can take over services back after being recovered. During IP address failover, services are switched from faulty to available, ensuring service continuity and improving reliability of the file system or the storage system in that sense. This process is not seen or transparent by to the users, so you will maybe not feel it unless you're running a really slow network. Then you might feel the jump from one port to the other port. But generally, if you're running a very fast network, 10 gigabyte Ethernet network and all this stuff, you will not feel this failover process in that sense. So the essence is service switchover between ports. The port can be Ethernet ports, bond ports, VLAN ports, doesn't matter which technology you use. Either way, possible. Ethernet port-based IP address failover. So to improve reliability of paths for accessing systems, you can create logical ports based on Ethernet ports. So when an Ethernet port that corresponds to a logical port fails, the system will basically fail over the port, right? So this is what happens. So here you have port A. So for some reason you have logical address for port A. So when you're accessing port A, you're using the logical address or logical Ethernet address for the port A. If logical port A somehow fails, right, you switch over to logical to port B. The logical port address is still the same, but the actual connection now is port B. This is a physical connection. So just like a primary standby in that sense, right? So locate an available Ethernet port of the same type, delete the logical port from the faulty Ethernet port, create the same logical port on the available Ethernet port, carry the services, ensuring connectivity. This is the port switchover stages. Okay. Bond port based, basically based failover. This is if both bond ports fail, you can switch over to a different bond port. Usually you will take both the ports to fail together, then you have an issue, right? In most sense, this might not happen unless they like you have bond ports on server 1 and bond port on storage 2 and so forth. Yeah, maybe one storage controller went down, so both the ports on the storage controller went down or something like that. Then yeah, then you can fail over to the second storage controller or something like that using the bond port method. But still ensuring a logical IP address. So you'll see the logical IP address is basically how you access. This is like you want to use HSRP and all that, kind of understand the theory, right? Nobody has issues with this. So some people have sometimes people have a hard time understanding the logical IP address and stuff. So the concept is fairly straightforward, whereby you will have two physical servers, right? Let's say you're accessing via this user. Let's just draw a picture to make it easier. Okay. Okay. Maybe these servers are connected to each other or something like that. So physical server 1 will have an IP of 10.0.0.1. Physical server 2 will have an IP of 10.0.0.2/24, of course. But you'll give them both a logical IP of so you say logical IP, LIP is 10.0.0.3/24. Okay. So when users want to access either one of these servers or whatever, they will use this IP address because this is the logical IP address set on both servers. The physical IP address will be 0.10.0.0.1, 10.0.0.2. but the logical IP address will be the 10.0.0 street. So this is the IP address the users come in. So if in case one server fails, basically the IP can switch over to the other server. Same concept they're using for bond ports. Make sense? So most likely this guy will be the primary state, this guy will be the standby state, and that's how they use it. So you just jump from the primary to the standby. And that's how you establish like some kind of high availability, right? VLAN based failover, same thing. VLAN based failover, however, you will still use different physical ports. So most of the time the problem will be the physical port itself. A physical port went down, so you'll switch over from VLAN with Ethernet port A with VLAN ID 1 to Ethernet port B with VLAN ID 1. That's it. Okay, but still using the logical IP address in that sense. So you'll still access from the same IP address, just at the back end they're using a different port now. Cool. Now we talk about fiber channel SAN. Okay, let's see what fiber channel SAN can do for us. So fiber channel SAN, by default, if you want to use it, you must buy a fiber channel HPA. There's no way around it. You have to buy the fiber channel HPA. The fiber channel HPA will convert its Scuzzy commands to fiber channel package or FCP, right? Which will not consume all the host resources and stuff by default, right? Then you have your fiber channel network. So it goes on to either your fiber channel switch network, your point-to-point, or even your arbitration loop, whichever network you choose, okay? Fairly straightforward. So fiber channel network. Here they add a lot more ports, okay? So you can see here E port. Expansion port is connecting towards the fiber channel router. Then you have the target, and here will be actually like a node port. This guy will be also a node port. This guy will be also a node port. Okay, yeah. So you have three different fabrics here, right? You have fabric 1, fabric 2, fabric 3. These are all connected via the router, fiber channel router, to contain like edge fabrics. So edge fabric 1, you have host 1. Edge fabric 3, you have host 2. I mean target 2. And then edge fabric 2, you have target 1, right? This will be using routers, fiber channel routers and switches. This guy is generally very expensive, right? I keep saying very expensive, but it is true. You can go check the price of a fiber channel router if you want to do like this kind of routing. So generally for host 1 to reach target 1, he has to create a zone on this switch to this switch, right? So there has to be a zoning here. There has to be some kind of fabric. So to create a zone between the switch, he has to have a zone from here to here first, right? So it's one zone. And then they will create a zone from here to here, this second zone, and then finally from here to here. And here to here also will be one zone by here. So later we'll see zoning, you'll get the idea a bit more. But just understand there are different types of ports. E port for expansion. Expansion port is generally used to connect routers to switches or switches to switches itself, expanding the switch. That's the E port. The EX port is basically used to connect switches to routers. So this EX port, this tree will be EX port on the router itself. On the switch will be an expansion port. On the router will be EX port. Okay. So nothing much to talk about other than that. Okay, zoning. So zoning is a concept that you'll find in fiber channel. This is how they achieve that high level of security. Zoning can be done both with WWPN or WWNN. And WWNN. So we already know what these two guys are. WWPN, so it's World Wide Port Name. Just copy the worldwide again. The second one will be worldwide node name. So what's the difference here? So how do I do zoning? So first I will select my port. So this will be a node port. and then I will connect it to a switch. Let's say there's a switch in between. I'll connect my node port to a fabric port on the switch, right? Then I'll connect another fabric port. So let's just call it F. Cannot see the F, but anyways, the fabric port will connect to the storage. This is a one-to-one connection. Very simple, very straightforward. Okay. So I will do a zone whereby we'll create a zone something like this. So server to switch, switch to storage. SVR, SWC, SEO. Okay, server, switch, and storage. I will set, if I want to use worldwide port name, I will set each port, so each individual port will have its own unique worldwide port name. So I'll say only this port connecting to this port creates zone 1. Okay, this port connected to this port creates zone 2. So I'll name this zone server SVR to switch. See, now I'll name this SWC to STO. And inside the switch, I'll say SVR to SWC is allowed to see SWC to STO. So that's one zone. So basically, I'm creating one big zone here. So this guy can see this guy. If I do not specify this inside the switch, this is using abbreviations. If you use the worldwide port name and all this stuff, it will be much more complicated. But I have to specify which unique port connecting to the switch, connecting to the server is allowed. If that port fails, basically the connection is down. So like if you go to my previous picture just now, so like if you take this, oh no, okay. Man, okay. So if you use worldwide port name, basically this is there. Let's say this is port number 2, this is port number 4, this is port number 6, and this is port number 2, right? If the port fails, the connection is down. You cannot just simply take another wire, connect it to another port. It will not work because the worldwide port name is a unique identifier for the port on the server. So each port on the server will have its own worldwide port name. Maybe the port name will be 0001 for port 1, 0002 for port 2 or something like that. But it will have its own unique name. So if I set zoning using worldwide port name, it is only from that port to that port can be connected, and which port to which port can be connected, and they can see each other. I must specify which ports and which ports can see each other. So here, what I will do is I'll specify, it generally won't look like this, but I'll just say SWR or SVR to SWC can see SWC to STO, right? So basically the main thing is the can see part here. How you do it in Fibre Channel is different, but I'm just making it easier for you guys. So I have to specify this in the switch. So I have to specify this like some command like this, that this connection can see this connection. Then they will establish a connection. If I do not do this in the switch, they will not be able to connect to each other. And this is how I create one zone. Now I have zone 1 in the switch. Right? So zone 1 is SWR can see SWR to SWC. can see SWC to STO. Okay, and you will specify even like this. If you use WW port name, worldwide port name on port 2, port 4, you can see SWC on port 6 to STO on port 2. You have to really specify the port number, which port they can see from, everything, right? That is how you do zoning in some sense. So what they are showing you here is 3 different zones. So basically you have 3 storages here. You have storage 1, storage 2, and storage 3. In the middle, definitely, even if you don't see it, in the middle, definitely there will be a switch, or maybe a switch here also. Maybe another switch here, depending. I don't know how the environment is. Or it can be just 2 switches or whatever. But generally, if you want to do something like this, you'll have 3 switches. You'll have 1, 2, 3 switch here. So switch 1 will be for zone 1, if you want to do it properly. So server will connect to the switch will connect to the server, done. Okay, maybe you have a redundant connection and all this stuff. Maybe you have like another switch here for redundant, up to you. Then you'll have server 2 connect to the switch, connect to storage 2. That will be for zone 2. Then you have zone 3, whereby your server will connect to the switch, and your switch will connect to storage 1 and storage 2. So you can see the difference here. Okay, so zone 1, server 1 can access storage 1. Basically straight away connection, no problem. Zone 2, server 2 can access storage 2, no problem. Zone 3, server 3 can access storage 1 and 2. Okay, but you'll realize their zones don't overlap. I mean, their zones overlap, but they can, this server cannot ping this server. This server cannot ping this server, and this server cannot see each other. That is what you call zoning, right? So this server will only see its own traffic going to storage 2. This server will only see its traffic going to storage 1, and this server will see its traffic going to storage 1 and 2. But they will not see each other's traffic. And that's how zoning works. Any questions?
Question, sir.
Yeah, go ahead. Go ahead, sir.
So one switch must be on in the one zone, or we can setting like VLAN. So one switch can be one zone, zone 1 and zone 2 like that.
You can. Nowadays you can set multiple zones on a switch. But to do the multiple zoning, you will have to use port name. You cannot use worldwide node name. Because worldwide node name, what happens is the whole switch is one node. So they'll use this address for one node, right? So when you set, okay, zone 1 to this node, allowed to zone 2 to this switch, and then you use the same node name here, so there will be some issues, right? You cannot use the node name. But if you use worldwide port name, yeah, it's simply like VLAN.
So one switch just can, one switch just can be one, what the name, port name?
You can have one switch with either one worldwide node name or one switch, depending on how many ports on the switch.
Okay, but one switch can be have more than one port name like that.
Yes, because each port on the switch will be one port name. So whatever ports on the switch. So that will be a single port name. Each port will have its own unique ID. So to achieve that, like if you want to just use 2 switches for this scenario, usually what we'll do to save money, we'll do something like this. Storage 1 connect to switch 1, storage 1 connect to server 1. Storage 2 connect to switch 1, storage 2 connect to switch 2, storage 1 connect to this switch, server connect to this switch, server also connect to this switch, server also connect to this switch. Make sense? But then they will do the zoning properly using the ports. So they'll say this port can only see this port can only see this, and then you segregate the ports. So they will be a bit more, let's say a bit more complicated, but can be done. Make sense?
Okay, good.
No issues. Any other questions? So zoning is a concept. You just have to understand how it works. When you actually go into the storage environment, then yes. I always say this. I always say it this way: take the certificate first, pass it, then study. Right? So just pass the exam first, get it out of the way, then you go and study, because it is a lot of things you actually need to know. If you want to do this during work, yeah, it will kill you. But as long as you have the certificate, okay, that's a problem solved. Then you sit down and then you say like, okay, I want to learn more about zoning to feel a bit more easier. Before that, you want to take the certificate and then study together. It's going to screw you up. So just focus on passing the exam first. After that, understand the technology. That's the same thing what I did. So first focus on passing the exam. I actually don't remember how much is my passing mark. And it's not a very high mark also. It was like 800 plus only, right? Some people calculate it as high. I just barely passed the instructor score so I can become an instructor, right? But after that, yes, I went inside and sit down and study all the storage topics and all that one by one. So I had more time. So I would suggest that is the way how to do it. Because nowadays everything is about certifications. If you don't have the certificate, you can't teach the class. You don't have the certificate, you can't get a job. So yeah. So if you want to understand zoning, zoning is not a simple theory. It's like learning VLAN all over again. It's a lot of things you need to know. If you want to see a simple zoning, come on. So a simple zoning command, you'll see down here, maybe you can find something. Oh, don't have. And let's see command. So yeah, you will usually, this will be your WW, this will either be a port name or this is more like, I think, a node name. So this will be like your WW worldwide node name. So you'll generally do aliases. So li create, so host 1, this is the alias I get the host 1, and this is for host 2 maybe, right? Or port 1, port 2. So they're doing port, I think, worldwide port names. So this is port 1, this is port 2, and then you'll do your storage. So V7, whatever, your port 1, port 2, port 1, port 2. So node 1, node 2, and all these things. Then you'll create a zone. So the command will be slightly complicated. You need to understand your, what do you call this? Your aliases. You'll generally not use the worldwide node name or the worldwide port name. You'll generally use the aliases or alias. And this is how we create the zone. So here you have host 1. So basically this guy up here, host 1 on port 1, port 0 maybe. From this port connecting to this port in one zone. Host 2 from this port to this port in zone 2, right? So then you can establish a connection here and there. Make sense? Then you'll create, of course, like maybe this is your SAN switch and all that stuff. And you go further and further and further. So you'll create one zone. Okay, this port is in this zone, this port is in this zone, and then you'll establish a connection. Make sense? So understanding the CLI commands comes later on. You don't have to straight away go try to understand them now. It will eat up all your time, believe me. But just understanding this is how zone works. Okay? Any other questions? Right. So then we compare. Yeah, go ahead, sir.
Storage they cannot be accessed by all the server.
Sorry, sir?
Storage 3. Storage 3 cannot be accessed by any server.
This storage basically is dummy storage. No access anywhere. So it's not in the zone. Maybe they will create another zone 4 where server 1 can access the storage or something like that. But yeah, generally now storage 3 doesn't have access. But at least on this picture. which is a waste of money in my regards, because you have a storage here, but yeah, I don't know why they put it, just to show you. So this storage is outside of the zone, nobody is connected to it, hence, yeah, maybe it's just a loose storage somewhere there. Okay, this guy is already quite wealthy. He has 3 storages already. It's quite massive, right? So comparisons between IPSAN and FCSAN. So they just have the DAS architecture here. This is just for fun. So DAS architecture is just connected via Scuzzy. So you can see the IPSAN architecture is using IP addressing, and the Fibre Channel architecture is using Fibre Channel. That's the difference. This is full redundancy Fibre Channel architecture. However, you will see these 2 switches are not connected together. In IP, you can connect these switches together. But in FC, if you want to do zoning properly, generally we will never connect these 2 switches. So this switch will be in one zone. They'll have maybe this guy to this guy as one zone. One connection. This guy to this guy as one connection. And then this is one connection. And this as one connection, right? So eventually, say this switch fails, they will use this connection to create a zone. So this is zone 1, okay? Excluding this guy, not this connection. This guy will not be in the same zone. So it's a bit delicate, bit hard to understand how they do it. But once you get into the configuration, it's pretty simple. So generally, you will not have the 2 switches connected together, because when you have the 2 fabrics connected together, then these 2 switches automatically will think they are in the same zone, right? So you don't want them to think they are in the same zone. You want to segregate the zones, so you separate the switches. But however, for IP, you can do this. So IP usually will have a connection between the 2 switches, right? If anything happens to the switch 1, at least switch 2, yeah, straight away switch over, no problem. FC, you will not have the 2 switches connected together. Okay? So this is how IPSAN and FCSAN looks like. This is fully redundant. You can say kind of redundant already, because if anything happens to connection 1, you still have connection 2. It's just that they have a different zone for that, maybe, right? So comparing between the architecture or network architecture of IPSAN and existing SAN, FCSAN, sorry. IPSAN uses existing IP networks, no problem. FCSAN, you have to build your own dedicated fiber channel network. Transmission distance for IPSAN, theoretically not limited because of how IP address works. For FCSAN, limited by the number of transmission distance of optical fibers. Management and maintenance, IP is as long as you have some kind of network management system, should be fine. FCSAN, you have to buy some kind of technology, some kind of FC management technology, not cheap. Compatibility for IPSAN, yeah, compatible with all network devices. So all your normal Ethernet switches, no problem. FCSAN, you have to buy fiber channel switches and all this stuff. Cost-wise, generally IPSAN is cheaper, much more cheaper, and FCSAN is higher cost, but then you have better bandwidth, right? Disaster recovery, IPSAN is much more easier to set up. FCSAN is not that hard to set up, but it's costly. Security-wise, IPSAN is relatively low because you can do packet sniffing, and FCSAN, you would have very high security, right? So generally, all those big companies use fiber channel because of the security and the the performance, right? Okay, then the final one, distributed architecture. So let's see how many they have. Okay, just not much. I think can finish it quite early today. I don't want to go into another chapter. Don't worry. I think you guys have already. Or are you okay to go to another chapter after this? Up to you guys. I feel like you guys already have too much to think about. Today we went through a lot of different types of protocol, RAID 2.0, different types of protocol here and there. So what do you guys think?
Yeah, too overwhelming today.
Don't worry.
Overload, sir. Overload.
Yeah. Okay, so we'll just finish up this distributed storage. So currently I think the time is about 5:20. It'll take about 10 minutes. Okay. So distributed storage architecture, this is how it physically looks like. So physically it looks like you're connecting to a server. So all these are actually servers, right? In cloud architecture, you are not connecting to storage devices, right? These are actually just servers that you buy off the shelf. You pump in a lot of disks inside the servers, and then you connect them via software. So it's actually all software connection. So you have some kind of software to virtualize all these servers. But actual connection is you're connecting to a physical server, right? So you have your front-end service network. So this is where users connect from. You have your management network for managing all the servers. And then you have your back-end storage network to manage all the storage of the servers, right? So not front-end network, users connect to the network. Management network manages the whole network, the back-end, front-end infrastructure, everything. And the back-end storage network is to connect to the storage devices, which is a bit of a weird concept. But anyways, the nodes here are actual servers. They don't have storages, right? They don't have storage. So it's just servers. How you get your SAN and NAS in a cloud environment is virtualized storage. So each of these servers will contain their own disks. So they'll have like 10 disks here, 10 disks here, and all that stuff. You add all the disks of all these 5 servers. So let's say this server has 10 disks, this server has 10 disks, 10 disks, 10 disks, 10 disks. They will just collect all the resources from all 10 disks, virtualize them into one big storage pool. But physically, it will look like this. Make sense? Physically, this is how it looks like. It's just a bunch of servers connected together, right? They are usually connected via a distributed network, whereby every server is connected to multiple switches for maximum redundancy and stuff. So each server will have like 2 connections, 3 connections to different switches to increase the high availability product, right? After they are connected, then you will use some kind of then they will use some kind of software to virtualize the resources. So the virtual resources are basically what you are getting in a cloud and network, right? You're not getting at the actual physical resources. It's virtual resources virtualized from all those physical resources, put into a big pool and given to you. So front-end service or front-end network. So the front-end service or tenant network is used to interconnect the distributed storage with the customer network. It provides tenant UI for users. Like if you want to see how a tenant UI looks for users, I have a Huawei Cloud account. You can see Huawei Cloud here. Maybe you guys have AWS accounts and all this stuff. Yeah, but I'll just show you. This is how it looks like as a tenant, right? So now I'm logged into my tenant network. So I'm going inside my network and I'm inside Singapore now. So here I can go and buy my servers, so I can create my servers and whatever. This is what I see. So whatever servers I am buying here, in actual fact, so if I go here and buy the servers, so I'll just show you. So yeah, make it cheap. Yeah. Put everything as free as I can. So this is not a cloud class, don't worry. But I'm just showing you, right? Yeah, why not? Public IP and stuff. Go ahead. So all right, next. So this is how it looks like a user. Now I'm just buying a server. I'm running the server. Okay. This server will come up and then I can use the server. But these are all just virtual machines, right? This is where I get all those virtualized resources I'm running now a server for 2 virtual CPU, 4 GB memory, CentOS and all this stuff. So that is actually taken off for how you see the front end network. User environment, that's what I see. Huawei will see something else. Huawei will have their management network, their internal network and all that. That is totally different, something I don't see. This is where they achieve their high availability, their interconnections and all this stuff, their component subsystem, the management network, all that is done by them, right? So generally what a user will see is totally different from what a a provider will see, which it makes sense, right? User, they make it quite nice for you, it looks easy and all this stuff. So I have my server running. If you guys want to go and putty into the server or whatever, you can. So you can just generally go inside the server. So this is 119.h.180.6. This is a public server. So you can go inside. If you want to know the password for this server, basically the password is, oh, sorry. Yeah, that's the password for the server. The username is root. So if you want to go and log into the server, do whatever you want, go ahead. Up to you. But generally, this is what you will see as a tenant, right? It's same in AWS, it's same in Microsoft Azure and all this stuff. But the back end, they will have their own environment. So they'll have their own environment to manage their network, manage their storage and all this stuff. They will have the storage backend network and the network management backend network, or what they call the management network, right? So the management network is used to interconnect with customer maintenance network. It provides a management UI for the system administrator to perform service operations such as system configuration, tenant management, resource management, all these other things. So these in a cloud service provider or cloud service environment, these things are all done by the vendor. The only thing you get to do is this, right? So that is the basically how distributed environment works. You are not like my server here. So my server here, which is I'll just paste the IP also here if you want to connect. So this server here is basically a virtual product of multiple different physical servers. So my server doesn't sit on one physical server, it sits on maybe like 10, 15 servers in the back end. Virtualized product, right? So they're getting the resources from 10, 15 different servers, adding the resources together and providing to me as one virtual machine. That's how the distributed architecture works. So with that theory, even if you say you have 10 servers, like say I just have 3. So all these 3 servers are providing some of their resources to create my server, right? So to create my virtual machine, my VM. So even if this server fails, they can just take resources from this server and push it to my VM. So at the end of the day, that is why distributed architecture is so powerful. Because until all the 3 servers fail physically, then my virtual machine goes down. But if just 2 servers fail, even 1 server fails, as long as they still have resources, they can dedicate more resources towards my virtual machine. And my virtual machine will always stay up. They can go then and fix those physical servers, change the servers or whatever, but my virtual machine will still stay up. This is why you get your 99.99% availability, right? And your reliability because of how they save data. So that is availability, right? Reliability is like this. Every time my virtual machine saves data into the storage, I'm actually not saving data into one server. I'm actually saving data into 3 servers. So let's say I have, 1 MB of data. The 1 MB of data will be saved here, and then the 1 MB will be replicated here and will be replicated here. So server 1, 2, and storage 1, 2, and 3. If storage 1 fails, my data is still in storage 2. Storage 2 can fail, my data is still in storage 3. So my virtual machine can just access the data in storage 3, right? This is the 3 data copy concept. Right? So for every 1 MB of data, I will save it into 3 different locations. And this is how you achieve your 99.9999999%. How many nines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have to add 1 more 9. So 11 nines reliability in sense, right? Very, very powerful concept. Okay. So network planes, you have private client access mode and standard protocol access mode. So private client access mode, basically you are accessing via your, let's say your client management node. You go to either a storage or compute node. So you can see here VBS and all this stuff. VBS is volume backup service, RAP, EDS, all these are actually cloud terms, right? You'll find it in Huawei Cloud. This is done most likely in a private cloud environment. This is also done in a private cloud environment, but yeah, this is how they look like. So you don't have to remember the network planes and all that stuff. Just understand how distributed storage network works or how distributed storage works, and you are golden. So network rules, nodes must be placed in a cabinet from top to bottom as usual. A deployment solution is usually chosen based on the project requirements. The total power consumption, weight, and storage node switches, the kernel virtual machines in a cabinet must be calculated, and the number of nodes that are housed in a cabinet must be determined based on the equipment room conditions. How cold is the equipment room? What kind of cables, where the cables are coming from up or down? How much space in between the racks and all these things. All these things you have to follow. There's a lot of rules actually. Typical configurations. So nodes and switches in the base cabinet are connected to network cables and SFPs. And the nodes and expansion cabinets connect to switches in the base cabinet through network cables and optical fibers. Normal. Right. So which of the following are included in distributed storage networking? So we just came from here, right? Don't worry. You have management network, front-end service network, and back-end storage network. Yes, right? Cool. Second one, which of the following protocols are commonly used in SAN networking?
Is Crc.
Is Skazi. Fibre Channel.
That's it. Simple, right?
Yeah.
So we have gone through storage network architecture evolution. We have seen DAS, NAS, SAN, and distributed architecture. Inside SAN, we have gone through IP SAN, FC SAN, and the differences between IP and FC SAN or comparison. So more information can be found here. Some recommendations can be found here. And thank you. So that will be chapter 2.5. Tomorrow we'll go to chapter 2.4 because I didn't want to do this chapter because this is a chapter we'll spend some time. Okay. Want to keep it light. But I know already a lot of information today. So we'll keep the situation light for today. We'll leave it at that. So I'll delete my server here. Destroy this guy. I don't want to pay your money, right? Okay. Let the guy be deleted. Done. So we will stop for today. Is that all right with you guys? And we'll start tomorrow at 9.
Questions, sir?
Yes.
No worries, right? So I'll give you back basically 25 minutes of your life, and have a good day, good one ahead, and see you guys tomorrow.
Question, sir.
Yes, go ahead, sir.
About the lab, are we tomorrow? We will do the lab.
Most likely is Friday, sir.
Oh, Friday. Okay. Okay. Thank you.
No worries, no worries.